The following is an excerpt from the Siphon Updraft full stack AI-powered website building course/tutorial. In this excerpt, you will learn how to build the T-Sender website, which is a production website which helps airdrop tokens more gas efficiently. In this excerpt, you will use AI tools to build literally any website, and you'll learn the power to be even smarter than an AI when it comes to building these Web3 powered websites. So that when they get something wrong, because they will, you will be smart enough to correct them. If you want to watch the full course, be sure to go over to Siphon Updraft. It is 100% free to begin learning to become a smart contract developer, full stack engineer, or website creator, or whatever technical prowess your heart desires. Links to resources are in the description of this video. And with that, get ready to build this fantastic website, and I'll see you on the other side. All right, welcome back. Welcome to section 2 of the AI Vibe Coding Full Stack Web3 Developer Crash Course, where once again, just want to remind you, we need to get things correct here, because if we don't, we run the risk of getting hacked for billions of dollars, and we don't really want to do that. We're going to be leveling up a lot here. There is a lot we're going to be learning, and we're going to be building a site that actually exists today. tsender.com is an actual website you can visit where we can go ahead, we can connect our wallet, connect to MetaMask, connect, and we can actually send transactions, and we can actually airdrop a ton of ERC20 tokens to different people. There's a safe mode and an unsafe mode. On this site, we have some different supported chains, including Ethereum, Optimism, Arbitrum, and of course, ZK Sync. And we have an Anvil connection as well for testing. Now in our MetaMask, if you do not have ZK Sync, one of the things you're going to want to do is scroll down. There will probably be a button to add ZK Sync. If you scroll down in your MetaMask, MetaMask actually comes with ZK Sync built in. You can just click add and approve, add it to your account, and you will be on ZK Sync here. What we can do is we could look up like the USDC address on ZK Sync, on the ZK Sync Tokens Explorer. We could grab the ZK Sync address here, paste it in, and what we can do is we can type in a list of recipients to receive this token and a list of amounts. So maybe I'll say I want this person to receive 100 or this much way, and we'll switch from Anvil to ZK Sync. We'll confirm, and what our UI will do is it'll tell us at the bottom, okay, we're going to be using the USDC contract with this much way, which equals to 1 USDC or $1. And then you'll click this button, which will call a function to approve the contract, and then a function to actually send the tokens to this list of addresses. If you have multiple addresses and multiple amounts, the bottom here will add them up, and you will airdrop the amounts to each recipient here. This is the tool that the CodeHawks team actually uses to airdrop tokens to the winners of the different competitive audits. So you're getting a little bit of a sneak peek into some of the behind the scenes of how CodeHawks and the Siphon team build different tools, both for internal use and of course for external use. This was the code base here. The code base for this is on this T-Sender GitHub repo. The smart contracts for this are in this T-Sender GitHub repo. And if you go into SRC, some of the contracts are written in this language called Huff, which is this like crazy gas optimized language, which is why this was created in the first place. This is the most gas efficient airdrop contract on Earth because it's built in this very low level language called Huff. So now if you go to the code associated with this, this is going to be the final project, the final code of what this is going to look like. And this is a lot bigger than what we did last time. This is a Next.js or React project. Next.js and React are known as JavaScript frameworks. They make doing a lot of that kind of complicated stuff that we got to towards the end, like compiling the TypeScript, a lot easier for us. And they make it easier for us to build more complicated, more extendable applications. So because of that, there's going to be a lot more code. In this, we're going to be working with a lot of different projects like Rainbow Kit. We're going to be working with WagMe, which is one of the most popular tools for creating these React apps. and so much more. This site we're going to be building completely statically, and we're going to be deploying it and hosting it using a platform called Fleek. Fleek has a lot of fantastic tools and is one of the sponsors of this full stack curriculum, and I'm super excited to deploy. And if you want, you could even deploy for free this application to Fleek. So with that all being said, this is what we're building. This is what we're going to make. Let's go ahead. Let's get cracking. All right, so here we are back in our code base in our VS Code. We're going to go ahead and get started setting up this new project. If you haven't already turned off your live server from the last project, now is a great time to do so. I'm going to cd down a directory, do pwd, make sure I'm where I want to be, and now create a new directory called ts tsender UI cu, which stands for TypeScript tsender UI Cypher updraft. I'll hit enter and I'll do code ts tab tsender UI Cypher updraft, or once again, we can do file open to open this up in a new window for us to focus on. We can go ahead and click the final code here, scroll down in here to click on this to see the smart contract code as well, if we would like to. So let's talk about what are we going to do here. Let's create a new file, readme.md, enter. What are we building? Well, a whole bunch of stuff, but this little image here kind of gives us an idea of what our website needs to do. So let's write it out. So number one, and if we go to the actual code base, the smart contracts are here. We can go to the tsender. If you go to src, actually don't go to protocol, go to reference. You can see kind of a Solidity written implementation, which is really, really, really simple for this smart contract. The main function that we need to implement is just this one single function, Airdrop ERC20. It takes as inputs an ERC20 token that's going to be airdropping, a list of recipients, a list of amounts, and a total amount. So an ERC20 token, now for those of you who are unfamiliar with what an ERC20 token is, in the GitHub repo associated with this section, there's a video called Create Your Own Blockchain ERC20 Token, where you only got to watch like the first 2-3 minutes to see what an ERC20 token even is. There's a link to this in the GitHub repo associated with this course if you're unfamiliar with a token. The quick explainer is essentially an ERC20 token is a contract deployed to a blockchain that represents a token. That's pretty much it. So yes, Ethereum is like a cryptocurrency in that we use to pay for gas, but you can also deploy tokens to the Ethereum chain as well. So each one of these chains have their own contract address because a token is essentially just a lump of code. So we need to pass which token we want to airdrop to people or send to multiple people, a list of recipients, and then a list of amounts. So this token address is going to be the ERC20 token. The recipients are going to be the list of addresses to get the token, and the list of amounts. So, and the way that the recipients and the amounts kind of link up, like if this is the, address A, address B, address C, if this is like the list of recipients, and then we say like 100, 200, 300, and this is the list of amounts, address A would get 100, address B would get 200, and address C would get 300. So this is index 0, this is index 0, index 1, index 1, index 2, index 2. That's how you decide which recipient gets which amount. And then obviously the total amount, which should be the sum of the amounts here. So this is the function that we're going to have to implement. So right at the top, we can just say implement this function. But before we even do that, we need to create a basic React/Next.js application. And it should be a static application. So as I mentioned before, the code for this, there's a lot of code for this. The reason is because this is going to be our first Next.js application, which is a little bit more complicated, even for something as simple as this. So we're going to have to create some boilerplate code, and then we can implement this. And we're not going to worry about the static part for now. Once we have all this up and we've tested it on our local chain, we're going to deploy to Fleek. you, at the end of this, can have your own tsender.com, on a different domain, obviously, and deployed to IPFS as well. Yes, at the end of this, you can deploy a contract. And when you do so, you should go to Twitter or X or whatever and be like, oh my God, I deployed my first full stack application. Here it is. Obviously, you're going to have some readable text here instead of what I just did. So, but we're incredibly excited because not only are you going to be able to interact with real contracts, but you are actually going to deploy a website yourself. And like I said, anytime you're looking to build an application, you need to have a badass front end. You need to have a badass website to interact with that smart contract. So we are going to do it here. And I'm so excited for you to do it here. And you should be super proud, and you should be super excited and super proud to get to the end of this section. Because if you've never deployed a website before, we're about to do it. If you've never deployed a website that interacts with blockchain, we're about to do it. You will have a website done, a badass website done by the end of this. So I want you to celebrate once we get to the end of this, because this is going to be so exciting. Okay, so these are kind of the basic things that we have to do, but we're going to take it step by step. Let's get started just learning about what the heck this React Next.js nonsense is, and let's go from there. All right, so let's go ahead and get cracking. Now we're first going to create a basic React/Next.js application. Now, I'm not going to spend a ton of time explaining what this is and what this means and going deep into it, because there's so much information out there already. And because the JavaScript world moves so fast, oftentimes these frameworks update and change and this and that and the other thing. At Cypherin, we're less interested in teaching JavaScript. We just want to teach blockchain technology. There's plenty of places out there to teach you JavaScript and Next.js and React. Not a lot of places to teach blockchain. AIs also are phenomenal at Next.js. They're phenomenal at working with the tooling that we're going to be working with here. So I'm going to skimp over some React details, some Next.js details, but I'll tell you when you should, maybe pause if you don't understand something, maybe go to your AI, ask some questions. And of course, we'll be doing a little bit of AI question asking ourselves. React is the most popular JavaScript framework for building websites out there. It was created by the Facebook team, and pretty much everyone uses it. Next.js is built on top of React and is created by the Vercel team, which is one of the most popular website hosting companies out there. So by you learning React and you learning JS, you are learning the most popular tool out there, which comes with the benefit of being highly used by a lot of AI. Now, to get started building a Next.js application, we're going to open up our terminal. And since we already have pnpm installed, you can follow the Next.js documentation to find the command, or we can just run pnpm create next app at latest. And this will go ahead and start creating our project. What's your project name? Well, it's going to be tsender or tsender. Would you like it to be script? Yes, we're going to use TypeScript. No, we don't want to use ESLint. And then you can kind of do like left or right to choose. Tailwind CSS, this is going to be, so TypeScript, we're going to use TypeScript instead of JavaScript. This is something called linting. Don't worry about that for now. Tailwind CSS, this is going to make styling our HTML much easier. We're going to hit yes. Would you like your code inside an SRC directory? SRC stands for source. We're going to say yes. Would you like to use app router? We're going to select yes. I'll show you what that means in a bit. Would you like to use TurboPack? We're going to say yes. We don't need to worry about that at all. Would you like to customize the import aliases by default? I actually prefer this, so I'm going to say yes. What import alias would you like configured? I'm just going to hit enter, and it's going to go ahead and install and set all of these up for us. If you have a custom setup that you prefer, obviously feel free to do whatever you want to do. Now I'm going to hit clear. If I open up my terminal, I see it created another folder, so I can now cd into tsender UI. If I do pwd, I have tsender UI, tsender UI. If you want to leave it like that, that's fine. It's going to kind of annoy me, so I'm actually going to shift click all of these and paste them here. And it's going to take a little time to copy, and it did. And now I should be able to delete this. Let's just make sure all the files got moved over. It looks like they did. Okay, so now I can delete this one, move to trash. Great. And now that we've got this set up here, we can look in our package.json and we can see we have this set of scripts here. Now these scripts are basically little shortcuts for us to run some command. Now this Next.js project comes with kind of like a boilerplate project for us. So if I pull up the terminal, I do pm run dev, this will start up a little server for us, and I can copy this, I can paste it into my browser, and I can see this is the little website that our application made for us. And now I'm going to come back here, Control C, clear it out, and delete everything there. So let's just kind of briefly walk through the files that are in here so that we have a good idea of what we're working with. So tsconfig, we worked a little bit with this in the last section. This is basically going to be our TypeScript config. So React and Next.js, whenever we run this pm run dev, it's going to essentially compile all of our TypeScript into JavaScript, and it's going to use this config to do the compilation. We have a README, obviously we have a README copy, which the Next.js application created. I'm actually just going to delete this. We have this post css.config.mjs. This helps our Tailwind CSS, which again helps with formatting of stuff. This is a lock file, which tells us specific versions of different dependencies that we're going to use. This is our package.json. This has all of our dependencies with not the super specific versions, along with some scripts and some details about our project. We have a next config. This is the Next.js config. So when we compile TypeScript, this tells us how to compile the TypeScript. And when we run our Next.js project, this tells us how to run the Next.js project. Ignore this file. Don't do anything with this. This is the git ignore. You can ask your AIs about this one. Then we have src/app. Basically, 90% of the code we're going to be creating is in this src folder. We have favicon, which is just like a little logo. Globals.css. This is like some formatting, so it gives colors and when to use certain colors given different, setups. We have our layout.tsx. This is going to be the layout of our entire app. You can almost think of this layout.tsx as the main function of our website. And then we have page.tsx, which at the moment is our home page. So if I have pm run dev running, and I'm going to minimize it, not delete it, just minimize it, right? I'm going to hit this X. I'm not going to hit the trash can, so it's still running. And I can refresh and it's still running here. I could look for, get started by editing src app pages tsx. I could look for this. I'll do Command Shift F, or just hit this little search bar over here, paste this in. Let's look for get started by editing. And we see that is on this page. So what's interesting about a lot of these files is that these are TSX files. And, let's say instead of get started by editing, I wrote, hello, I saved it. I go back to our front end. Now it just says hello. What's interesting about these files is that they're in TSX instead of .ts. So you might see that and be like, what's the difference between .tsx and .ts? .ts is TypeScript, so what's .tsx? Well, this is where we can ask our AI. So .ts is a regular TypeScript file. .tsx is a TypeScript file that includes JSX or React components. So in these TSX or JSX files, we're allowed to create these things called React components. You'll notice that like in this export default function home, we almost have like HTML and JavaScript. So React.js allows you to create these React components, and they're essentially these different functions which are a weird combination of HTML and JavaScript. And it's one of the reasons why React became so popular, because essentially, back in our raw HTML and JavaScript project that we did recently, we had our HTML in one section, we had our JavaScript in another section, and we combined them at the end. In these JSX or TSX files, you can kind of combine them even more. And it's pretty interesting. You'll see as we play with it more and more, what it looks like. But essentially, There's a lot going on here for us to start with. So we're going to cut everything down. So I'm just going to say, okay, delete all of this. Goodbye. Goodbye, all this. See ya. And I'm just going to do div hi, hit save. Now if we go to the front end, let's look for this. Now it just says hi. Great. Layout. We're going to change. We're going to delete all of this here. We don't want any fonts. We're just going to make this super, super minimal. Instead of create next app, we're going to say tsender, no description. We're going to get rid of all this here and refresh. And that looks good. So cool. Much more minimal layout, super minimal page. We can even get rid of this top one. Globals.cs can stay the same, but okay. So this is what your layout.tsx should look like. And this is what your page.tsx should look like. And this is where we're going to start from. Now, if you want to take some time, pause the video, pause the course, and start playing with this and start trying to build this yourself, I highly encourage you to do so. But if you want to code along with me, let's do it. We are, like I said, we are going to be using AI to help us out a lot here. So great. So now we have a super minimal React site that does pretty much nothing other than say, hi, let's go back to our README. What are we supposed to be doing? Create a basic React.js application. I guess we did that. Great job. So next is we want to implement this Airdrop ERC20. Now, obviously this comes with a ton of stuff. We first off need to connect our wallets. So before we even implement this, let's connect our wallet with a nicer connect application. So let's walk before we can run. Let's connect our wallet. So back in our HTML TS Coffee CU, we had this connect button and it wasn't very good, right? If I pull this back up here, when we connected, it would say connected, but it would still be a button. If I refresh the page, it would no longer say connected, but then I would hit connect and it would be connected. But then if I disconnect, it would still say connected, but if I hit connected, then it would show up and I would connect and then it would be connected. And it just wasn't quite right? Remember, right? I just refreshed again. It says it's not connected, but it clearly is connected. So we want to have a much better, nicer interface for users to connect their wallets to our application. Because what we currently have going, because the way we did it kind of stunk. So what we could do to do this, and let me just put a couple of notes here. So we could write a ton of logic to store some local cookies on the device to say, okay, yes, this person connected with this wallet and on this address and remember it. And if they refresh, hold this. And if they disconnect, remove the cookie. And, we could add all this logic ourselves. We could just use a package that already has all this logic. And that's what we're going to do instead, because we want to work incredibly hard to be incredibly lazy. And I want to make this a little bit nicer than what you see here, right? You go to Aave, we open the app. One thing that they have that's really nice is they have this header up at the top with this connect wallet. If I connect with MetaMask here, MetaMask pops up, I can connect, and they give me this fun little address thing here. Oh, it says I'm connected with this address, and then I can disconnect, I can reconnect. Oh, wow, that is so nice. If I refresh, it remembers that I'm still here. I want that. How do I get something like that? Well, there are a lot of different wallet libraries out there that automatically do a lot of this for us. And the one that we're going to be using is this library called Rainbow Kit. Why are we using Rainbow Kit? Well, quite frankly, it's because I liked it. And because it works great with this tool called WagMe, which is what we're going to be using. So for those two reasons, it works well with WagMe, which is a tool we're going to be using. And I just kind of like it. That's why we're doing it. So we're going to go ahead. We're going to copy this line at rainbow.me, rainbowkit/latest. And this is at rainbowkit.com, or, use whatever is in the GitHub repo associated with this course. And we're going to stop our website here. And we're going to do pm add at rainbow.me/rainbowkit@latest. Now, as of recording, we're using version 2.2.4. So if you want to use the exact version we're using in this video, you can do pm add at rainbow.me/rainbowkit@2.2.4 like this, instead of doing @latest. So that's how you can get a very specific version here. So now that we have this installed, we can go ahead and actually get set up with creating a header, which has this. We can go ahead and get started creating this wallet. So if we go to the docs, it looks like we actually have to install a couple of other components as well. These ones right here. So I'm going to go ahead and copy those, and I'm going to install those as well. pm add, wagme, VM, and tanstack. So we're going to add those as well, and those will show up in our dependencies here. Then if you want to pause the video, follow along with the docs, feel free to do so, or you can kind of follow along with me, what we're going to be doing here. You can follow along with the docs, but I prefer if you just follow along with me here because I'm going to be doing it a little bit differently than what the docs do. So to work with Rainbow Kit, you want to come up with a config first. And it doesn't look like they have a, okay. So they have a little bit of information on the config here, but we're going to create our own config. So in the src folder, not in the app folder, create a new file called Rainbow Kit config.tsx. And this is going to have the code to tell our website what kind of chains we can connect to, how to connect to our site. So first at the top, we want to say use client. This tells a React component that we want this stuff to run on the client side, AKA in the browser, which is what we want. And we're going to do a little bit of boilerplate here. So we're going to do import get default config from at rainbow-me/rainbowkit. And then we're going to import our set of chains that we want to use. For us, I'm just going to say Anvil and ZK sync. We'll say from wagme/chains. And then we'll say export default, get default. And this will be our config for our wallets. So these will be the allowed chains that our application will allow. And we're going to say our app name. It's going to be tsender. We're going to have a project ID, which I'm going to leave blank for now. You'll see why in a minute. And then we're going to say the chains, which for us is just going to be Anvil and ZK sync. And then SSR is going to be false. SSR stands for server side rendering. At the moment, we're going to try to make this a static site. Now, what is project ID? So according to the docs for this, every dApp that relies on Wallet Connect now needs to attain a project ID from Wallet Connect Cloud. This is absolutely free and takes a few minutes. So with most applications, let's go back to Aave, for example. And let me disconnect my wallet here. Whenever you connect a wallet, you'll pretty much always have, MetaMask or Rabby or some type of software wallet like Brave or Coinbase. But if you go to other wallets, you'll also get this little Wallet Connect QR code that you can either scan or copy. So there's lots of different types of wallets out there that also want to connect to these different apps, but maybe they don't have a native integration, right? MetaMask, Brave, Coinbase, these all have native integrations. They can just kind of automatically connect to Aave. But maybe you have like a Ledger or a Trezor or some other type of wallet that this application doesn't support. Basically, for every other type of applications, there's this company called Wallet Connect, which will essentially facilitate a connection between your wallet and the website. Now, for a website to use Wallet Connect, you have to sign up for a Wallet Connect project ID. Now, you can 100% not use Wallet Connect, but for the most part, it probably just makes sense for you to use Wallet Connect. It doesn't hurt. So what we can do is we want to go over to Wallet Connect and we want to sign up. So I'm going to log in with an account here. I'm going to sign in with my wallet. Message looks fine to me to sign. I'm on Ethereum mainnet, which is kind of spooky. Maybe you want to log in with your email and username if you're not how to sign stuff. I've gone ahead and logged in. And now what you can do is your project will have a little project ID that we're going to go ahead and copy. And what we're going to do is we're going to create a new file called .env.local. And this is where we're going to store some kind of sensitive, but not super sensitive credentials, such as our project ID. So I'm going to paste my project ID in here. And now I can say next public wallet connect project ID equals, paste this right here. So I don't know if I'm going too fast for you, feel free to pause and do that. And having this project ID will give us access to this wallet connect modal so that people with different wallets that our website doesn't support can still connect to our website. So for project ID, I'm going to say, to get this environment variable, I'm going to say process.env.next public wallet connect project ID. I'm going to save it, and I'm going to put a little exclamation mark here, which means that yes, this 100% will exist. So there's a couple steps to getting this header in. This is the first step. We create our config here. Awesome. Okay, what's next? And at the end of this, we're going to have a nice little modal like this, but this is step one. Of our app here, we're going to create a new file called providersx. Now, this is going to be a list of tools that are going to wrap around our entire application. And one of the tools that's going to wrap our entire application is going to be this Rainbow Kit config. Why do we want to wrap it around our entire application? Well, we want everything inside of our application to know about our wallet, to be able to access our wallet. So we're going to create this page called providers, where we're going to provide a lot of stuff about wallets. So I'm going to say use client because I want this to be on the client side as well. And we're going to say export function providers. We'll say props, children, React node. If this doesn't make sense to you, that's totally okay. Just ignore it for now. We're going to say import type React node from React, this. And in here, we're going to say return, little parenthesis, Rainbow Kit provider. We need to import that as well. So we're going to import config from @/Rainbow Kit. So this little @ sign means inside of our SRC folder, go to Rainbow Kit config. And since we imported this as the default, we can just call this config. And we're also going to import the WAGMI provider from WAGMI, which is again something that we haven't used yet, but I promise it'll make a lot of sense soon. And in here, we're going to say WAGMI provider config equals config like this. We'll put this in here. We're going to put props.children in here, and then we're going to do /WAGMI provider. Oh, and sorry, we need to do import Rainbow Kit provider from @Rainbow me/Rainbow Kit. We need to do this, and cool. So what is this page going to do? I know this is a little confusing. Let me explain. So we set up our config here, which is going to tell our header, our wallet, what chains we can connect to. Now in this providers component is essentially going to wrap around everything in our entire application. This WAGMI tool is this thing that we're going to use to interact with the blockchain. So when we did raw HTML and JS, we use this thing called VM. WAGMI is built on top of VM. And we want WAGMI to be kind of encompassing everything that we're doing. So you see that inside of WAGMI is the Rainbow Kit provider, and inside of the Rainbow Kit provider is this thing called props.children. You can kind of think of this as like all website code will be in here. So all website code is going to be essentially inside of this WAGMI provider, if you will. So now that we have this providers thing, which has kind of the WAGMI and the Rainbow Kit provider, we can finally go back to the layout, which you can, like I said, you can kind of think of this as our home base. And we have export default function root layout. I don't love the way that this is set up, so I'm going to delete all this, and I'm going to instead say props children React node like this, and I'm going to import React node from React, and this will be props.children. And now I'm going to do import providers from /providers like this. And I'm going to do providers. So what do we do just now? Well, when we run our website, essentially we go to this layout.tsx page, right? And I could put like, hey, from layout. And now if we run this, we refresh our app. No query client set. Use query client provider to set one. Oh, I forgot. We actually have to also in our providers add a query client provider. So we'll do import, and you get a lot of this from WAGMI, which I probably should have shown you first, but that's okay. We're gonna do import query client provider from tan stack query like this. Just roll with me for now. It'll make sense. And here we're going to say const query client equals useState. That means we need to install useState. Just kind of blindly follow along with me for now. I promise we'll explain in a second. Import useState from React. Okay, is new query client. And then finally, inside of WAGMI, we're going to do query client provider. Client equals query client / query client provider. Now let's kill and rerun. Go to our front end, refresh the page, and it's now working. In my layout.tsx, if I wanted to, I could say hi from layout, and we would see hi from layout in here. Okay, so everything flows through this layout.tsx. So everything in our application is going to be wrapped around this set of providers, because in providers, we're basically saying everything is wrapped around these three things: the WAGMI provider, query client provider, and RainbowKit provider. Why, Patrick? Why the heck did we do all that work? It doesn't look any different. Well, like I said, it'll be helpful later for when we actually go use WAGMI, for when we go to read and write to and from the blockchain. But for now, it looks like a huge waste of time. But it's okay, because all of that work is going to make a lot of sense soon. So in here, we have these RainbowKit providers. And what we can do is we can, now that we have all of this set up, all this provider stuff set up, we can add a connect button that comes directly from RainbowKit. So we have the RainbowKit provider. We can do comma connect button and take this and go connect button inside of here. And this will give us that connect button from our last project, but with a lot more bells and whistles baked in. So now if I go to the front end, it says wrong network and wrong network detected, switch or disconnect. And all the formatting is messed up. So we got to go fix the formatting somewhere, and your provider's file works fine. You need to add the RainbowKit styles. So we'll do import at rainbow-me/RainbowKit/styles.css. And that'll apply all the styles to it. And now if we refresh, we get a much nicer looking connect button here, where I can connect, and whoa, nice little pop-up will show up saying connect a wallet. What is a wallet? MetaMask pops up. We can choose our account. I'm going to choose my account 1, and we can choose our network. I'm going to just go ahead and hit update and connect. And what will happen is if you hit this little drop down, it'll make you choose between wallets that are actually supported. So right now, I've set it up that only Anvil and ZK Sync are chains that work. And it's causing a little bit of errors because my Anvil instance isn't up. So my MetaMask is like, what's going on? But if I switch to something like Ethereum, it'll say wrong network. Please choose a network this application works with. I'll hit ZK Sync. Okay. Connect. And we can see we are connected here. And because in our config, I told you this was going to make sense. We only have Anvil and ZK Sync in here. Those are the only two options we get on our front end. Mainnet to Anvil, Ethereum, to Anvil, ZK Sync, and mainnet. And we added mainnet to this list here and saved. We go back to our site, select this drop down. We now have Ethereum as an option. And if we click it, our wallet will pop up. Now it's going to move over to Ethereum. So I can click it again, move back to ZK Sync, go over to ZK Sync, and it's now happy. Getting a little bit of issues with this connect button because of where this is. Let's actually take this connect button out of the providers. Let's go to page for now. We'll put it in here. And then, so that means we're going to take this line, paste it in here, get rid of this. Now let's refresh. Now let's switch to Ethereum. So now on our app, we'll go ahead, we'll connect our wallet. Oops, that's super zoomed in. Oh, connect to MetaMask, where we'll go ahead, we'll connect here. once you start from disconnected, put that earlier, once you start from disconnected. Now you can see I'm on the Ethereum network. I'm on the Ethereum network on the app. We'll change from Ethereum to ZK Sync. And since I've already approved for ZK Sync, we're now on ZK Sync. And we can switch to any network we want. Okay, excellent. Let's keep going. So let me just kind of back up and explain what we did here, because we did a lot of stuff and I told you just kind of roll with me, but let me have it all make sense. So the way that this providers.t, so you can kind of think of everything going through our layout.tsx file first. So when you kind of boot up the page, when we start our application here, you can almost think of everything getting started from this root layout or this layout.tsx page. And this props.children, you can basically, and this props.children piece here, you can basically think of this being any page that we have show up on our app. So for example, page.tsx, this is what's going to show up on our app. And you can almost think of kind of copying this thing and pasting it here. And that's kind of how the app works. Now, the reason we want to wrap everything in this providers thing is because every single page that we're going to deal with is going to want to interact with providers or something at some point. So we're going to want to interact with WAGMI, which again, we'll show you that soon. We're going to want to interact with the query client provider, which again, we'll show you soon. But especially we're going to want to interact with the Rainbow Kit provider, because the Rainbow Kit provider is this thing that gives us access to all these nice little features and connecting our wallet and disconnecting our wallet and such. So on our layout.tsx page, we wrap every single page that we render inside of our providers here, so we can give access to every single page, at least the Rainbow Kit, so that every single page can have access to a wallet. If we didn't do this wrapping thing, then on every single page, we'd have to do like, import, what is in here? We'd have to do import Rainbow Kit provider, import the connect button, import rainbow styles on every single page. And that's super redundant, and we don't want to have to do that. So having this set up makes it so that we don't have to write as much code. Our code can be much more maintainable, much smaller. And that's how you can kind of think about it. In order to pass objects to tags inside of tags, you kind of have to wrap them like this. So if that doesn't make a ton of sense, please consult your AI companions, or if they are not being helpful, ask questions in the GitHub discussions. All right, cool. Let's keep going. Now, before we continue on, if we go to tsender.com, we see that there's kind of a nice little header here. Now, we want to have this same functionality so we can separate this header from all the stuff that renders in the page. Because if we have different pages, we still want the header to render, and we don't want to have to retype all this code for doing the header code every single time. So we're going to create our first component inside of our folder. So a component is going to be like a reusable chunk of React code. Basically, that is just this header chunk. And anytime a page gets created, it just calls the code for this header chunk that we're going to create here. So in our src folder, we're going to create a new folder called components. And components are a really well-known, well-documented concept in full stack programming. And again, if you want to learn more about components, go to the Next.js docs, ask your AI, go to the discussions, etc. But in here, we're going to create a new file, header.tsx. And this header.tsx is going to contain all the code that we want to have this header and contain like our connect button and everything. What's really nice is guys are great at creating headers. So if we want, we could even just go to our AI. Again, my favorite at the time is Claude, but DeepSeek works great too. You can even turn on the deep think for here. And here's what we're going to say. I'm going to copy all this code here, and I'm going to say, here's my connect button for connecting my Web3 app to the blockchain. And I'm going to have these 3 backticks here. I'm going to put all the code in here. Then shift enter. I'm going to say, can you turn this into a reusable header component with GitHub link /button, right? Because that's what we see here. A title called tsender, connect button on the right side. So what's nice is we're already giving DeepSeek the code to use this connect button, so it doesn't have to use some random library. If we want to be even more specific, we can say, can you only use the following imports? We have our connect button import. We have this GitHub icon from this React icons package, which is pretty well known. So we can get this little GitHub icon.
We do have to install this if we want to use it though. So I'm actually going to kill this. We do pm add, and this is called React Icons. React Icons. Let's look this up. React Icons. So pm add React Icons. Enter. Okay, clear. And then go back to DeepSeek and next image. This comes built in with Next.js. Let's go ahead and hit enter and let's see what DeepSeek gives us. So notice some important things. We didn't tell our AI that we're using Next.js, but it should be able to figure out that we're at least using React based off of this code here, right? Because this code is clearly a React or a JSX or a TSX component. We probably should have told it that this is TypeScript, right? Because there's no typing in here, but we do want to be using TypeScript and there's no typing here. So we probably should have told it that we want TypeScript. You can kind of see it's thinking here, which is great. And it actually even says right here, let's plan the JSX structure. So it did figure out this is JSX. It didn't figure out that it was TSX because there was no indication here that this was TypeScript. And when we're prompting our AIs, this is something important to know, how much information are we giving the AI so that it's able to deduce what we're doing? We didn't give it any information here that it could have used to deduce that we're using TypeScript. You can almost think of this AI as like a human being. A human being would have seen this and said, oh, okay, that's JSX. I'm going to use JSX. And let's see what it gives us at the bottom here. Okay, so here's this header component. We're going to copy it and we're going to paste it into this header.tsx. I don't see any big issues here. We have your username, so we're going to change this to Cyphren, tsender. That looks good to me. And then to use it in your page component, do it like this. Okay, great. So let's go back to our page.tsx. And instead of this, we're going to do import header from @/components/header. And then instead of connect button, we would do header here, right like that. And let's see how it did. pm run dev, do a little refresh here. And that looks pretty good. A little GitHub icon here, tsender, a little bar. This is great. If you want to add more styling to this, you can. But this is a pretty good example of our AI giving us some pretty good code here, right? This header component is relatively minimal. And what's important, again, as I've said many times, anytime your AI gives you something, you want to make sure you understand everything that's going on. All of these class names here, these are styles associated with Tailwind. So if we go to like Tailwind docs, go to the documentation, we want to go to Tailwind version 4, get started. You can see that Tailwind has a list of all these different keywords that they can use in your code, like background color. So if I did like BG red 50, right, as a class name, so I'll put BG red 50, I'll save it, go back to tsender. So for example, I would have changed this from BG white to BG red 500, which stands for background red 500, and go back to the front. I now see this header is now completely red, right? Because that's the Tailwind class name CSS. So, okay, cool. So I understand what all these are doing. We could go to the Tailwind documents and figure out which each one of these lines are doing. But again, it's just some styling. We have an A tag, which is going to be a link. We want to make sure we understand what all these are doing. Target equals blank, which means it'll open it in a new tab. Rel equals no open, non-refer. This is some helpful tooling for kind of preventing tracking. Class name, hover, text, gray, 600 transition colors. This is so that when we hover over it, it changes color, which is pretty cool. And the like. So you want to make sure, like I said, anytime you're using AI generated code, you understand what every single line looks like. These lines look pretty good to me. So great. Now we have a header component. We can actually reuse this all over our project, but I'm going to go one step further because I don't want to have to, go to every single page and do import header, blah, blah, blah. So instead, the last piece that we're going to do is we're actually going to write in our layout.tsx because every single page is going to come with a header. We're going to do import header from @/components/header. And we're going to stick the header right above props.children. So now every single page is going to automatically come with the header, automatically come with the connect button, which is going to make navigating our site much easier. And we don't have to keep importing the header into every single page that we create. Now, if we go back, we obviously have double headers here. On the page side, I'm just going to remove the header export default function home. And now we just have hi. Nice. Now, if your AI didn't give you a good suggestion, you can always come to the Sender UI Siphon Updraft course and grab the header that is located in here instead. So feel free to always refer back to this if your vibe coding doesn't vibe that well. Okay, so step 2 is done. Connect our wallet with a nicer connect application or a nicer connect feature. We are now connected. This is fantastic. Now, step 3, implement this function. This is a pretty overloaded step. There's obviously a lot to do here. We want to call Airdrop ERC20 from this website. Remember, if we go to the actual website, we have a form to take a token address, a list of addresses, a list of amounts, a little transaction details here, a send tokens, and then we have a safe mode and an unsafe mode. For the purpose of this course, we're going to ignore the unsafe mode. That's kind of like an additional feature that the actual site has. We're just going to focus solely on this safe mode. So we don't need this back and forth bit. We're only going to focus on interacting with one single contract. So obviously, to do this, we're going to need a number of things. We should make a little component just like we made the header, right? So the header component is going to be this top part here. And then we'll make a intake form component, which will be this bottom part here. And then we'll combine the two on our page. So in the layout, we'll have the header here. And then on our page, we'll have it render the intake form. And then if later on we want to extend the application, we can have that form show up on multiple pages. We could just implement the intake form here, whatever we want to do, but I want to have it a little bit more modular. So I'm going to create a new component called airdrop form.tsx. Now, if you want to try to vibe code your way to victory here, feel free to do so. However, for a big page like this, in my experience, I found AI can get a lot of things wrong. And if you don't really know what you're doing, it can be really hard to debug what the AI gives you and get it to be correct. So we're going to start building most of it ourselves, and then we'll flip back to AI to help work with the AI a little bit later. Because there's a lot of new concepts in this airdrop form that we're going to be working with, and we're finally going to work with WAGMI. So let's just go ahead. Let's get started here. Let's create this component, export default function, airdrop form, and then let's just have, for now, let's return a little div, closing div. We'll just have it say hi. And now let's stick this airdrop form in our page.tsx. So I'm going to say import airdrop form. Oh, thank you, GitHub Copilot right here. And then we'll just do like a little auto closing tag here, airdrop form. Oops, this goes here. And we'll refresh. Hi from airdrop, I should say save from airdrop. Okay, great. Okay, so in here, we're going to want at least 3 input fields, a token address, recipients, and an amounts. Now, to make this kind of standard, what we can do is we're going to create a little new folder in the components called UI, and we're going to create a new component called input field.tsx. And this is just going to be some code for us to make a nice little input field. Now, some boring template like this is something that AIs are great at doing. So we want to just be very specific, and we want to tell our AI exactly what we want this to look like. So let's go ahead and try that with DeepSeek. Again, at the time, my favorite is Claude v3.5. If you want, there's a link to this leaderboard in the GitHub repo associated with this course called the AI Leaderboard, the Chatbot Arena LLM Leaderboard. It's a community-driven evaluations for best LLMs and AI chatbots. For us, we specifically care about the coding chatbots. And if we scroll down in here, we can see what the leaderboard has for the top models and their rankings. This is good to use kind of as a rule of thumb, but as you can see, it has ChatGPT 4.0 latest as the number 1, Gemini 2.5 is number 2. I personally still think the rank 9 Claude 3.7 model is the best. So even though these can rank differently, there is still kind of a vibes-based pick your own winner based off of what you feel is the best. So these are kind of the top ones, but for me, I still think Claude 3.7 is the best. But by the time this video comes out, that might be totally different. Anyways, so something boring like a really nicely formatted input field is something that AIs can do really well for us. So we can come to our AI of choice. Remember, feel free to use the Arena leaderboard to take your pick. We might say something like, I'm going to say I'm looking to make an input field React component with TSX. it should take the following props: a label, placeholder, value, type, large, and on-chain. The label is going to be, this bit here. The placeholder is going to be what you see, when there's nothing in here. So like, this would be the placeholder. This 0x would be the placeholder here, or this would be the placeholder here. Value is going to be whatever is actually in it at the time. So the value of token address here would just be high at the moment. The type is going to be if it's a string, a Boolean, a number, etc. Large is going to be, and I should tell DeepSeek this, we'll say whether or not the text area is large. So this is like a single line. This is multiple lines here. And then on-chain, and I should tell DeepSeek here, the function to call when the area changes. And then I'm using Tailwind for styling, and let's see what it gives me. And I'm using the DeepSeek model here. Again, I'm using DeepSeek because it's free, but please feel free to use whatever model you like the best. All right, and let's see what it gives us here. This looks pretty good to me. Here's a reusable input component with TypeScript that meets your requirements. I'm going to copy it, come back over here, paste it in here, and let's see what it gave us. And let's make some tweaks in case we don't like it. So it gave us a change event handler from React. I actually don't like that. I am going to tweak this a bit. You might get something else. I'm going to change this to just a react.change event. Oh, it looks like GitHub Copilot has what I want. Change event. So if your AI didn't give you this, just go ahead and change it to this. Once again, if your AI gives you something terrible and nonsensical, copy paste what I have in here. And then what you can do is you can copy it, bring it to your AI, paste this in here and say, here is what my instructor gave me. What is the difference? Or something like that. And be sure to read whatever your AI gives you. This is a perfect opportunity to kind of work with your AI to learn what is going on for these basics, so that when these get more complicated, you can actually really understand every single piece of your application. So export default function input field, that's fine. Label, placeholder, value, type equals text, large equals false, on change, that looks good to me. And all of this code here. So we have a little label here that it's creating, great. We have this large conditional, okay. If it is large, the style, the number of rows is different. Otherwise, there's just going to be one row. And this looks pretty good to me. So let's try this out. Let's try this input field out on our Airdrop form. So I'm going to do import. Oh, and at the top, I want to do use client. I'm going to say import input field from @/components/UI/input field. Oh, and this is the default, so we don't need that there. And now in here, instead of hi from Airdrop, I'm gonna have a couple different input fields. So we'll do input field here, label will equal the token address, like so. Oh, why do I have a squiggly here? It's missing the properties. Okay, yep, makes sense. Placeholder is gonna equal 0x. The value is gonna equal, well, we want the value to equal whatever the user puts in here. So I'm actually going to create a hook at the top, which I'll talk about in a second. Const token address, comma set token address equals use state, like this. And then we'll import use state from React. I'll talk about this in a little bit if you're not familiar with that. So we'll say value equals token address. We'll say on change equals arrow function set token address target.value and / like this. Okay, cool. So on our UI now, we now have a little input field where we have this little token address label. Okay, cool. So this actually looks pretty good. Thanks, DeepSeek. Now let's briefly talk about this use state thing here. If you're unfamiliar with React, this is called a state hook. In normal JavaScript, whenever we want a variable, we would just say let token address, var equals this. And if we wanted to change it, we would just say, okay, token address var now equals this, blah, 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 or whatever. But in React, instead of doing that, we use this state hook mechanism. So it's very weird, but const token address is essentially the same as doing let token address equal, and then whatever's inside of the use state, so equal this. And set token address is essentially a function to update this variable. So like I said, instead of doing token address equals, some new address, blah, 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 we call set token address. So the equivalent of doing this with this state hook would just be, set token address to this. Now, this is very bizarre and kind of weird syntax if you're not familiar with it. But the reason that we do this is because we need a way to tell our website to re-render or update whenever this variable changes. So in our input field, we're saying every single time something in here changes, we should update this token address. And this is a lot more minimal than us writing some code of if that field thing that we made changes, this is some pseudocode, update the token address and then re-render the whole page, right? That could be kind of a lot of code and a lot of very messy code. So this is just a much easier way to do it in React. AIs are great at working with React. So if this is kind of confusing to you, take some time, ask your AI some questions, read the React documentation. But like I said, using this methodology, using this pattern will enable our website to re-render much easier than if we do const my, or I guess let my var equals 7, blah, 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 blah. So most of the time, if you have some variable that you want to update with your website, you're going to want to use this use state hook when you're working with a React component. It takes a little bit of time to getting used to, but once you're used to it, it becomes pretty easy to continue on. Okay, cool. So we have a token address field. Let's make another field. Do input field. Instead of token address, this should be recipients, or what is on the T-Sender? Yep, recipients. Yep, okay, great. Placeholder will be like OX, blah, 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 comma, OX, blah, 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 blah. Instead of token addresses, this is going to be recipients. This is going to be a new variable. So we'll say const recipients, comma, set recipients. Okay, cool. It'll change the recipients. Okay, cool. Go to our front end. Now we have a recipients. Okay, great. And this is going to be large equals true, like this. So now it has several rows. Okay, great. What's next? Let's copy paste this. We want an amounts. So we'll do like a placeholder of 100, 200, 300, . We want a new hook here. So this is going to be amounts, and set amounts equals use state. Value is going to be amounts. Function is going to be set amounts. Okay, that looks good. We do want this to be large. Okay, great. And then finally, and then that's it. 1, 2, 3 input fields. Okay, great. And the transaction details form will come in the bottom later. Okay, so if we go to our site, that looks pretty good. Token address, recipients, and amounts. Okay, awesome. Now, once these are all filled in, we want a little button at the bottom called send tokens. So let's create a button. We'll say on click equals handle submit. And this will be a function that we create anytime somebody clicks this button. So I'm going to take this, I'm going to scroll up. I'm going to say async function handle submit. And I'm just going to do console.log hi from submit. Okay. Now we should have a button at the bottom. Oh, submit or send tokens. Let's inspect console, send tokens from submit. All right. When I click it, we get from submit. Okay, great. The button styling is pretty terrible, but that's fine. Okay. So now we have our forms. The styling is terrible, but we'll fix that later. We're just worried about the functionality for now. We have our forms. We have our button that doesn't do anything. Let's make this actually do some stuff. Okay. Now here's where I can actually show you this use state stuff kind of working, right? So in our handle submit, what I can do is I can have this console.log out the token address, the recipients, and the amounts. So every time we change one of these inputs, it calls this set recipients function, which essentially updates these variables. So now that I have these console logs in here for handle submit, I go back to the front end, do a little refresh. If I put in like 0x000 here for recipients, I'll put in like hello here, and amounts I'll put in like 100. If I hit send tokens, it's going to print out the values that are in here. Because every single time we change these input fields, it automatically updates these variables, right? Which is really good, right? Without these state hooks, we would have to like create the function, like function update token. Okay, and then we do like, document.get element by ID, blah, 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 set the token address to that. And, we don't want to have to do that. These state hooks do that, and they do some other nice functionality for us. Okay, cool. So now we're getting the address, the recipients, and the amounts. Now we can finally connect to the blockchain and actually send this transaction. And this is where we can finally use WagMe, and we can finally use our blockchain, use our Anvil blockchain to do a little bit of testing. So let's talk about how this handle submit thing is going to work. When somebody calls send tokens, the first thing that we're going to do is we're going to have to approve the contract to have the tokens. So let's write a little playbook out here. So step 1, approve our tsender contract to send our tokens. Number 2, if approved, and then actually 1A, if already approved, move to step 2. Step 2, call the airdrop function on the tsender contract, and then wait for transaction to be mined, and that's pretty much it. So let's go ahead and get started with this first one. Approve our tsender contract to send tokens, and actually we should flip the order of these. We should check if already approved, move to step 2, otherwise approve the tsender contract. Because to move tokens through a contract, you always have to approve the contract first. So that's what we want to do here. So in order to approve the contract or check that we've approved it, we need the contract address and we need the token address. So let's first get the contract address. So we'll say const tsender address. And we can make this a constant in this variable here because we don't really need it to be a state hook, right? We only need this address when somebody's calling the submit function. And once again, we're going to follow a similar pattern to what we did in the HTML section. We want to get this from some constants file. So we're going to go ahead, create a new file, constants.ts. And in here, we're going to get the different addresses of the different contracts. Now, to make your life easier, we can just go to the tsender UI and just copy and paste the constants that we go to here. We can see the tsender and the tsender no check addresses. For this tutorial, we're only going to be focusing on the tsender. We're not going to worry about the no check. But we do see for chain 31337, we have a tsender address here, and that's what we're going to be mainly working with. We also see this comes with an EC20 ABI, and if we scroll down enough, we also have a tsender ABI. So we can just copy this whole file, paste it into our constants.ts, save it, and that looks pretty good. Now we have this mapping here, or this dictionary, or this JSON object, chains to tsender, which has a chain ID, and then a tsender address, and then a tsender no check address. Like I said, we're only going to be working with the tsender for this video. But now that I have this mapping, back here, I can do import chains to tsender. And let's actually get the tsender ABI and the ERC20 ABI as well from @/constants like this. And now the tsender address is going to be the chain ID and the, since we're only doing the tsender, or excuse me, tsender address equals chains to tsender, chain ID, and tsender. We do not have the chain ID though. So how do we get the chain ID? And this is important, right? Because if we're on a different chain, each one of these chains is going to have their own tsender address, right? So we're going to want to get the chain ID to figure out what tsender address we're on. So how do we get the chain ID? Well, this is where we can finally work with WagMe. So let's go over to the WagMe documentation to learn a little bit more about WagMe. So if we go to WagMe, we go to React, This tells you all about how to work with WAGMI and the WAGMI hooks and why you might want to work with WAGMI here. The reason we want to work with WAGMI is because we have all these hooks that work really well with WAGMI. One such hook is going to be use chain ID, which allows us to very quickly and easily get the chain ID as a React hook. The way we got our contract address before in our HTML project was we just had this constants file where we just had export contract address equals, and then we just had a single address here. But because, like I said, we're going to be on different chains, we're going to want to get this chain ID. You can get the chain ID using VM, but it's going to be much easier for us to just use this WAGMI hook, import use chain ID for WAGMI, and then we can just do const chain ID equals use chain ID. And that's it. So I'm actually going to copy this line from the documentation, pop it up at the top here. And now I can say const chain ID equals use chain ID like this. And why this is so helpful is because anytime the chain ID changes, anytime the user on the front end, I have too many things open. Anytime the user on the front end, updates to a different chain, this chain ID variable will automatically change for us, right? And this is, again, why we want to use these hooks, because if we weren't using this use chain ID hook, we'd have to code our own, bit of logic. We'd have to say, okay, if the user went to their MetaMask and they changed the chain ID, here's the new chain ID. Like, we don't want to have to code any of that. WAGMI has already coded all of that for us, and we get this chain ID here. And what we can do now is we can even do, like, to test this out, little console.log, tsender address, and console.log chain ID like this. And on the front end, let's just go ahead and refresh here. If we're looking at the console, if I click send tokens, I get the tsender address right here, and I get the chain ID of 324 because I'm connected to ZK Sync. This is the ZK Sync tsender address, and this is the ZK Sync chain ID. Perfect. Okay, cool. So let's continue handling the submit here. Now that we have the tsender address, what's the first thing we need to do is we need to figure out if the contract address has already been approved. So I want to get the approved amount. And to do so, I'm actually going to create a new function, async function, get approved amount. It's going to take the tsender address, which is going to be a string type, and it's going to return a promise of a number. And since it's going to return a promise, we know that we're going to have to call await here. And in here, we're first going to say if not tsender address, meaning if tsender address is null for some reason, like if the user is on some weird chain over here, we'll just do alert. This chain only, no address found. Please use a supported chain. And then we'll return 0 since we're returning a promise which resolves to a number. And now we want to read from the chain. We want to read from the chain to see if we have approved enough tokens. On ERC20s, they have a function called allowance, which tells us how many tokens somebody has approved for a certain contract. So we want to call this function. We want to call this read function. How did we do it before? How did we read from the blockchain before? Well, in VM, we created a public client, we called get balance, and then we just kind of consoleed it to the log. Well, this is to read a balance of a contract. We want to actually call a function. So how do you actually call a static function with WAGMI? Well, this is where we can go to the WAGMI documentation and go to React. We can scroll down, and they have a hook in here called use read contract. So it's a hook for calling a read-only function on a contract, returning the response. So the allowance function is going to be a read-only function. So that's what we're going to call. And we're going to literally follow the docs verbatim. We've actually already imported WAGMI, so we can just do import use read contract. Where is it? Right here, comma use read contract. And we'll scroll down. It says use read contract, and you pass in the ABI, the contract address, and the function name. And if you scroll down some more, there's a whole bunch of other parameters as well that we can do. And that's it. Now for this, we could use WAGMI's use read contract, which is a hook here that we could use in our app. However, since we're only calling this one time and we don't need the website to re-render, when we call this function, we're actually just going to use the raw read contract function instead of the use read contract hook. Now, this is something that as you get better and better with working with front end, you'll start to figure out when you should use a hook versus when you should just call the function raw. And you can also work with your AIs to ask it questions if you're unsure if you should use a hook or just call the function raw. So we have use read contract here, but we can also go back to the WAGMI documentation and we can just look up the core documentation, scroll down, and there is a read contract function right here. Action for calling a read-only function on a contract and returning the response. That's all we want to do. We don't need to keep track of state or storage or do any re-rendering or anything like that. So we're just going to use this read-only contract here. Now, since we're calling from the core code base, we actually have to install, I'm going to cancel this for a second, the @wagmi/core library. So we can do pnpm add @wagmi/core. Like so. And now that we've installed the core library, we can import it here. Import read contract from @wagmi/core. And then in our get approved amount, we can just call it directly. So we'll say const response equals and await, and read contract is a promise. So we need the await keyword. So await read contract. And we go to the documentation, we can see how this works. So we need to pass it a config and all the parameters in here. So what is this config thing? Well, this is why way back at the beginning, we created this rainbow kit because this is our config. So this export default get default config, this is going to be our config that we're going to be working with Anvil. We exported this default config, and then in our providers, app providers here, we have WAGMI provider config equals config. So this config here is basically telling our application how it can interact with the blockchain. And we could import this config and use it here, or WAGMI comes with a hook that we can use. So up at the top, we can import that in. So we'll just say, we're going to get use chain ID and we're going to do use config, and we'll use this as a hook. That way, same thing. If the config changes for some reason, it'll automatically update. But we'll say const config equals use config. And now we can pass this to our read contract. And then we can pass in all this stuff that we actually want to pass in. So the ABI is going to be the ERC20 ABI. The address is going to be the token address that's going to be received from our state hook. Now we want to make sure this is a string that starts with OX. So we're going to say as OX $string like this. And the reason for that is because our read contract function takes in a config because that's the type that our read contract is going to need. It's going to need this OX string. So token address is that. The function name is going to be allowance. And then the args are going to be, well, we're going to need to check who is getting the allowance. It's going to be obviously whoever calls this function. So we're going to need to get the account here. We can get the connected account with another WAGMI hook. So we're going to also use this use account hook. And so we'll say const account equals use account. So the args are going to be the account.address and the tsender address as, once again, an OX string. Works like this. Okay, so doing this like this is going to be the equivalence of, like, if you're doing a Solidity contract, it would be like token.allowance account tsender. That's essentially what we're calling, but we're calling it on the front end and we're calling it with React in this read contract function here. So this response will be like how much is being approved here. So then we can say return response as a number. So this is like we'll cast our response as type number. And now that we have this function, we can call it in our handle submit. We can say const approved amount equals await get approved amount with the t sender address like this. And now this will get how much is approved. For now, let's just do console.log approved amount. So let's just kind of put this together to see if this is working at a high level. Let's finally spin up our Anvil chain, get this started from the front end just to make sure that at least this contract interaction is working, right? Because we have our first kind of reading from the blockchain. We haven't really worked with WAGMI before. Let's just make sure that this kind of bit here is working as intended. So on our front end, we have our send tokens button, which doesn't do anything. Let's make this button look a little bit more like a button, just so that I know that I'm even clicking it. And to do so, I'm actually going to just prompt my AI. I'm going to say, here's my button using Tailwind. Can you make it look a little nicer? Let's see what DeepSeek gives us. Okay, wow, DeepSeek kind of popped off. But let's just copy this class name here because this is the actual styling that we want. So let's kind of paste this in. Wow, that is quite the pop off. Let's see what it looks like on our UI. Do a little refresh. Oh, I should probably start the UI. Okay, cool. Now let's do a little refresh. Okay, cool. Yeah, this does look a little bit better. Now our button looks kind of like an actual button. So cool. So right now calling send tokens, I'm going to get a bunch of errors because, well, nothing is filled in. So let's actually go ahead and let's start up our locally running node. Same as what we did in our last section. If you go to the GitHub repo associated with this section, there is already a blockchain here, tSenderDeployed.json, that we can use for our tests. So tSenderDeployed.json, I'm going to copy the whole raw file, new file, tSenderDeployed.json, paste this in here. And this Anvil blockchain comes already defaulted with tSenderDeployed, some mock tokens, and then obviously some default Anvil accounts with ETH gas already in them. So I'm going to go to my package.json, create a new script. We'll just call it Anvil, and this will run Anvil --load state tSender deployed like so. And now what I can do is I can do pm Anvil. TSender deploy. Excuse me, or deployed. Let's recall this tSender deployed and try this again. And cool. Now I have an Anvil instance running with all of my tSender stuff already deployed. So now on my front end, I can switch from my account. Let's go to the Anvil account that we imported, that Anvil one, and let's switch to the Anvil chain ourselves. And now we can see we have a whole bunch of ETH in here. Let me just refresh the page, get rid of a lot of those errors. And if we go to the GitHub repo associated with this, tSender UI CU, if we go to the contributing.md, I believe the addresses are in here. Okay, cool. tSender address, which is going to be in our constants.js already, but we also have a mock token address. Okay, so let's grab this. And it says, can use mint or mint2 function to get some tokens. Let's go to our UI, maybe pop open our MetaMask here. Let's go ahead and actually connect account so that it's account 8 connected to our UI. Let's go to tokens. We'll add imported token here, paste the token address, token symbol MT, token decimals 18. That looks correct. And this account 8 gets started with 100 mock tokens. Hopefully you can see that. It's a little bit off the screen. We can also expand the view. Yeah, 100 mock tokens. And again, if you haven't imported those accounts, what you can do is you can grab the private key 0 from your locally running Anvil instance and import it into your MetaMask, and you will have this account in here, right? So on the Anvil chain, this is the imported account 0 with 100 mock tokens. So on our UI, what we can do now is, well, we can go back to the README here. We can grab this mock token address, paste it in here. For some recipient, let's say send it to ourselves and send 100 to ourselves. Now, if we call send tokens, it should console.log the amount approved, which right now should be 0. So let's call this, and we do indeed see 0. We don't get any errors, which means we're doing something right here. Okay, cool. This is very exciting. Let's keep going. So we have our locally running Anvil node running with tSender, with our mock tokens, with everything. We have our front end running. Let's keep building kind of this main function here in our airdrop form. So we have the approved amount that we just console.logged. what do we need to do next? Okay, well, we say if we've already approved, move to step 2. Otherwise, we need to approve first, right? So let's go ahead and do that. So we'll say if result is less than the total amount needed. How do we get the total amount needed? How do we know how much we need? Well, if we're going to send 100, then we need 100 approved. If we're going to send 100 plus 100 equals 200, then we need 200 approved. Okay, so we need to count all the amounts to get the total amount needed to approve. So we need to actually create that function first. So up at the top, we're going to need to create a new hook. We're going to need to create a new variable that changes every time amount is updated. Well, there's a couple of different ways we could do this, but one of the ways is using something called useMemo. Now, useMemo is a React hook that caches the result of a function call, preventing unnecessary recalculations when the component re-renders unless that dependency is passed it to change. So on our site here, anytime this is updated, we should recalculate the total. But we don't want this to kind of recalculate if something up here changes instead. So what we can do is we'll create this useMemo thing. So we'll say const total, which will be a number, equals useMemo. And we're going to need to import this from React, useMemo. And this is going to be a function where we call calculate total, where we take the amounts, right? All these amounts, and we're going to add them all up. So we're going to create a function called amounts, and we should call this function anytime the stuff in here changes. So anytime amounts changes. So let me just do, so when we're doing useMemo or useEffect, which we'll use later, is we want to tell React to call this function whenever something changes. This is the list of dependencies. So if we kind of back this up, this is a valid line of React. What this says is anytime the amounts variable changes, call a function of console.log hi. And we can even just delete the const here, and I'll show you on the UI. Let me do a little refresh here. So if I change stuff in here, nothing's printed. If I change stuff in here, nothing's printed. But if I change something in here, it prints out hi. So that's how this memo works. This is a list of dependencies in this array. So it's saying anytime amounts changes, do this function. So let me back it up here. So what we want to do is we want to say anytime the amounts changes, recalculate the total and save that as a variable called total. So we need to create a function called calculate total. So we could put that right in the component here. However, I want to set it up as a util, just in case we want to use it later and we want to use it in other components. And this allows us to test it much easier if we separate it here, which we will be testing it. We will be writing some unit tests for this. So let's create a little util here, utils. We'll create a new folder called calculate total. And in here, let's create calculate total. And in here, new file, calculate total.ts. Now this is going to be TS, not TSX, because this is just going to be raw TypeScript. All we're going to have in here is the function calculate total, and we're going to take the amounts as an input, and then we're going to get back the calculated total. And once again, here's where AI can be really helpful. I can copy this line, go over to my AI, and I can say, here is a use memo I'm going to use. So I'm going to ask it, here's a use memo I'm going to use. I have the 3 backticks. I paste it right in here. I want to make a calculate total function, which takes a string in the format, and I paste a potential format here and adds all the numbers up. It can be comma or new line delimited. Can you make such a function in TS? So this will allow the user to create new lines or separate them with commas. And I could 100% code this myself. And if you want to get some practice coding such a function yourself, you should. But I'm going to go ahead, enter, and let's see what DeepSeek gives us. Okay, here's what DeepSeek gave me. I'm going to copy this. I'm going to paste it into my calculate total.ts, and I'm going to see if this is what I want. Okay, so we have it. And again, whenever you copy paste code from an AI, you want to read it line by line to make sure it's doing what you want it to do. I'm going to go ahead and spot check this. And if you don't understand any of the lines here, Now's a great time to pause and check what your AI gave you, and then maybe compare to what we have in the GitHub repo associated with this course. Okay, so amounts is going to be a string. It's going to return a number. This looks good to me. Const numbers equals amounts.split. So this is some syntax to split with a new line or a comma. That almost looks good. I think they need a plus here. Yeah, they need a plus here. So this is where you can get tripped up. This might look good to kind of the naked eye, but because I know what it's supposed to be, I know it's actually missing a plus. The plus means that any new lines or any commas, more than one. Without the plus, it's just kind of one, which isn't great. So I'm going to add the plus here. Okay, so then it's a .map string to string.trim. I don't like the string keyword. I wish it would name it AMT or for like amount. So I'm going to rename that. The trim is good. This removes white space. We like that. .filter amount should not be equal to empty. This is also good. We like that. And then it converts to numbers. This is probably okay, but I'd actually rather do amount to parse float AMT. Excuse me, AMT.parseFloat. I'd rather do it like this. So that's fine. Then, okay. I don't like the name numbers. I prefer amount array. Okay. And now I'm going to do if amount array dot sum is nan, or is not a number, is nan. Then we're just going to say return 0. And now at the bottom, return number or amount array. Oh, it actually did that here. Actually, that actually might be better. You know what? Actually, I do like what it does here. So I'm actually going to get rid of this. Okay, so we're going to filter out all the not numbers. Okay, that's good. And then reduce sum plus number 0. Okay, cool. So then we're going to just basically, this is the kind of key line that actually does the addition. This is kind of all the text parsing. And now that I've kind of reviewed it, it looks pretty good to me. But I want to make sure this is actually really good. So we're going to write our first unit test on a full stack on our code base here, which is really exciting. So like I said, in the blockchain world, getting things right is really important. It's really bad if you get something wrong. And as we're building and iterating on our websites, we're often going to make changes. So we want to have a test suite. We want to have tests for our code base here. And the reason I set up this kind of weird format of putting this in a folder and then having this calculate total folder and then a calculate total.ts file is so that next to our calculate total.ts, we can have a new file called calculate total.test.ts. And we can have our test right inside of here. Now, if you're familiar with like Python, you might be more familiar with tests being in their own folder. If you're familiar with Solidity, tests are often in their own folder. In full stack applications, tests can often live alongside the files themselves. In Rust code, you'll actually find pretty popular that often tests are inside the files themselves. So there's a lot of different places that tests are often put. And it's kind of up to you to figure out the methodology that you like best, because you'll see it a lot of different ways in a lot of different places. For us, for this course, we're going to be putting our unit tests in files alongside the actual files. And then we'll be putting end-to-end tests in their own folder. And we'll talk about end-to-end tests a little bit later. Now, if you're just trying to win a hackathon and code very quickly, you might skip doing some of the tests. However, in the long run, it's often much, much better to have tests early on, so that when you iterate and when you make changes, you can know that you're not going to break anything. So we're going to actually write some tests here. Now, again, this is where AI is very helpful, where you can ask it to help you write tests. However, once again, if we're going to be using AI to help us write tests, we absolutely want to make sure that the code it gives us is right. Because what is bad is if we use AI to write our functions and then use AI to write our tests, and we don't check what the AI gives us, it's just going to give us garbage, and then we're going to test garbage with garbage, and we're just going to get more garbage. So if you use AI to help write your tests, you absolutely 1,000,000,000% need to check what the AI is giving you. So I'm going to ask the AI to write us a test, and then I'm going to spot check it. If you ask your AI to write you a test, be sure to spot check it. or be sure to compare it with how we did it in the GitHub repo associated with this course. I'm going to say, great. Here's what I said to my AI. I said, great. Here's what I'm going with, the 3 backticks, the full function. And then at the bottom, I say, can you write me a test for this now? I'm going to use Vite test. You can use whatever testing methodology you want. However, for our unit tests here, I'm going to use Vite test. And I'm going to say, and have the test be in the same dir. And I'll hit enter. We'll see what it gives us. And once again, we're going to edit it based off of its output. So it gave us a little output. I'm going to copy paste it. And let's see how it did. Paste it in here. Zoom out a little bit. Describe, expect it from Vite test, which we need to install. Let's go ahead and look this up. Revi test Vite test. Get started. pm add -d Vite test. The -d means it is a dev dependency. This isn't something we need to actually build the website. It's only for testing. So I'm actually going to kill this for now, although I probably don't need to, but let's run this anyways. And we'll add Vite test. I don't know how to pronounce it, but that's okay. That red squiggly line should automatically go away. If it does not, we can restart the TS server. And instead of this, we can just do /calculate total, because it's going to be in the same folder, right? These are in the same folder here. And again, we can restart the TS server to get rid of that little squiggly, or maybe not. Is not a module. And then we also have to add, maybe did DeepSeek give us this? Yep, add it. Yep, create a vite.config.ts. We sure do need to do that. I'm going to paste or create new file, vite.config.ts. Paste it in here. Actually, instead of Vite, I'm going to do vite.config.mts. So this is where DeepSeek didn't quite give me what I wanted. And we're going to import define config from vitest/config. And for plugins, we're going to do plugins ts config paths. And so we need to import this to work with TypeScript. Import ts config paths from vite ts config/paths. And all this is available on configuring vitest. And this is in the documentation here. It looks like DeepSeek might not be the most up-to-date, sad face. But we need to add this as well. So I'm going to do pm add -d vite tsconfig-paths to work with this is a tool that allows TypeScript paths to basically work, and we're working with TypeScript, so we're going to want to do that. And we don't want for tests for here, we're going to say deps for dependencies, say inline wagme at wagme/core, and your comma here. And then we want to do exclude stuff, actually. You know what? Actually, to make this a little bit easier, I'm just going to tell you to copy paste mine from the GitHub repo. So we're going to go to the GitHub repo associated with this. We're going to go to the vtest.mts, and I'm just going to have you copy paste this, and then I'll explain what all this stuff does. So ts config paths, like I said, this allows vtest to work with TypeScript environment. This environment JS DOM uses JS DOM to simulate a browser environment for your tests. This is important because since we're going to be testing, since our app is going to be running in a browser environment, that's the environment that we want to test. This exclude is really important. We don't want to accidentally run any tests from node modules or from a test folder or from Playwright or from TS results. We want to only run those Vite test sections. And this dependencies thing tells Vitest to inline the WAGME and WAGME core libraries instead of mocking them. This means that the libraries would be like kind of bundled or copy paste directly into our tests instead of them being externalized. This actually isn't really super important since we're not doing any WAGME or WAGME core tests. But if you decide to add those, this is something that you would need to add. Anyways, now that we've added all that, we should be able to restart the TS server. That squiggly line should finally go away. It looks like it's not. We're getting the calculate total.ts is not a module. And that's, I did all that work kind of for nothing. That's because we need to export this. Export function calculate total. And now this goes away. Okay, cool. So now that we've done all that, we can finally look at what it's given us for some tests. So calculate total, it should handle basic cases. I actually kind of hate this as a test. I would rather this be like it should work with new lines 100 plus 200 to be 300. I'm actually going to copy paste this. 100 plus 200, 300 should be 600. It should handle mixed delimiters. I like that. 100, 200, new line 300. That should be 600. Good. 1.5, 2.5, 3.5, 7.5. Good. Some messed up stuff here to be 900. Okay, that looks good. It should handle empty input. I like that. It should ignore invalid numbers. I like that. It should handle decimals. I like that. It should handle white space. That's a good test. It should handle complex combinations. That's fine too. Okay, cool. Now to run this, we can just do pm run vtest. Oh, excuse me. Let's go to our package.json. Let's create a new script here. We'll call it test unit. And this will just run vtest like this. And then we can do pm run test unit, and it'll run vtest. Oh, and cannot find dependency.js DOM. Would you like to install it? Yes. Forgot to install that. Okay, and let's rerun the command to actually run the test. And it failed. Let's figure out why this failed. Calculate total should ignore invalid numbers. Expected 57 to be 45. So should ignore invalid numbers. Failed for us. Let's go to that file. What did it do? Expected 57 to be 45. So this is the line that failed. 12. Oh, so it did 12, new line 45. Oh, that's kind of cool. So it actually correctly added 12 to 45. I actually kind of like that functionality. So if someone does like 12.3 or 12, so if someone did like on our website, oh, I close it. But if someone did 12.3 and 45, it would actually do 57. I actually like that. So I think that that's good functionality. So I'm going to keep that in there. And once I save, it's actually going to automatically rerun. I'll print Q to quit, but I can run that again. And it'll print out all the different tests. 1 file's passed, 7 of the actual tests pass. And that looks good to me. What's nice about auto-generating tests is even if you disagree with them, like I kind of did, you can very easily edit them based off what the AI gives you to give you kind of what you want. So mine gave me this expectation that 12 plus 45 here would just kind of exclude this one. But because of the way that I created the calculate test, it actually added them up to 57. I actually like that functionality, so I'm going to keep it as such. And cool. So now we have a test for our calculate total function. And this is really important because like I said, we want to make sure our UIs add stuff up correctly, because if it adds something up wrong and we send a transaction with the wrong values, that's obviously very bad. So cool. So now we have a calculate total function. We can finally import it. We've tested it. Import calculate total from @utils/calculate total. And it's mad because that's not where it's located. One other thing that a lot of people do is for their utils, they'll generally create a index.ts file. And in here, what they'll do is you'll just do export calculate total. Thank you. From /calculate total. And this way in our airdrop form, instead of doing kind of this giant piece of code here, we can just say import calculate total from /utils, right? So this index.ts will be a file with all of our utils kind of added into it. And then no matter what util we want to use, we just say import calculate total from @utils, like that. Cool. So now we have a calculate total. We can finally figure out how much we need to approve. So we're going to have this total amount that's going to keep changing every time amounts changes, and it's going to keep being updated. And we can actually even see that. Let me restart it up. pm run dev. We'll refresh the UI. Hopefully I didn't break anything too hard. But for totals, connection refused. Yep, it's because let's also do our pm anvil. Let's also run our anvil node. Now let's do a little refresh here. So now what we can do is we could even have our calculate totals. We could even print out kind of the final bit here. So we could do, instead of calling calculate totals, we could say console.log calculate totals like this. And then instead of saving it as total, we'll just do that. Now on our front end, if I say 100, Looks like it's adding correctly. If I create a new line, do another 100. Now it's showing 200 correctly. If I add 200, it's printing out 400. And you can see every time I update this, it recalculates and adds them all together, which is what we want. Perfect. So let's undo that. Great. Okay, so now we have our total here. Now we can finally say if the approved amount is less than the total, which is going to be the total needed, then we're going to want to call approve. And this is where, once again, we go back to WAGME. We could either use a React hook to do this or just call the contract directly. Now, since the result of us calling this approve function, we are going to want to make some UI changes based off the answer here. We're actually going to do something a little bit funky. So if we go to the React docs of the WAGME, there is a use write contract hook, which we're going to be using. So let's go ahead, let's import this from WAGME. Let's do use write contract. And in the documentation, it gives us an example of how to use it, the different parameters. I actually want to scroll down to the return type and see what it returns. It returns a number of things. It returns write contract, which is a function we can directly call. It returns data, which is going to be, when it correctly works, it's going to be the hash returned. It has a write contract async, which gives us a function to asynchronously call the write contract function. And this is what we're going to use as opposed to the just regular write contract function. It also returns an error if there's an error. There is an is error / is idle / is pending to tell us when the transaction is going through. And these are all different things that maybe we want to capture to update the UI based off of this. So for example, when we send a transaction and we're waiting for it to be confirmed on the blockchain, we can have the UI basically say, hey, if the transaction's pending, maybe show like a little spinning animation. Hey, once you get the hash, maybe do this. These are all variables we can capture directly from this use write contract hook. And this is very nice because we don't have to code all that functionality ourselves. So we can get some of those in particular. So we can get that data piece, which we'll just call the hash because that's essentially what it's going to be returning. This way we can do something on the UI once we send the transaction. And we'll get the write contract async function equals use write contract like this, so that we can call different functions directly with this write contract async function. Now that we have that function, we can actually call the approve function down here. So we'll say const approval hash equals await write contract async. And this is where we put, pretty similar to the read function up here, we'll put all the parameters of what we need to call approve. Now we don't need to add the config like what we needed to do for read contract, since this write contract async is coming directly from the hook, right? If we scroll back up, read contract is just coming from the core. Use write contract is coming from WAGME, and this is a hook. And since it's a hook, it already kind of has context of our config and our state and all this other stuff. So for write contract async, ERC20 ABI, the address is going to be the token address. Once again, as an OX string. The function name is going to be approved. Thank you, ChatGPT. And the args are going to be the tsender arg as string, and then the total. Now, to be specific, I want this total to be a big int. So I'm going to wrap it in this big int. I'm going to wrap it in this big int wrapper here because our calculate total returns it as just a number. But for a lot of our function calls, it's much easier just to wrap it as a big int so you don't get any weird oddities. So this is how I'm going to do it. So this will give us the hash of the transaction once we send it to the blockchain, but we want to wait for this transaction to get mined, right? So a little confusing. We first send the transaction in our MetaMask, then we want to wait for it to get mined. To do that, once again, we can decide if we want to just wait directly by using a function or we want to use a hook. For me, I don't want to use a hook. I just kind of want to wait directly. Once again, the more you work with this, kind of the better you'll get at figuring out which one you want to use. So since I want to just call this directly, I'm just going to grab it from the wagme/core, wait for transaction receipt. So now I'm going to say const approve all receipt. equals await, wait for transaction receipt. And since I'm calling it directly, I do once again need to pass the config since it's not coming from the hook. And I'm just going to say the hash is the approval hash. So if we go to the docs for this, oh, did I spell that right? Response. If we go to the docs for the wait transaction receipt on WAGMI, we can see some basic usage here. You pass the config, you pass the hash, and that will wait for that transaction to finish mining. Cool. So once we've done that, if it's approved, we can say console.log, approval confirmed, and then we'll do comma, approval receipt right here. So since this is our first time actually writing a contract, sending a transaction, I actually do want to test this out kind of manually to make sure it's actually working. So let's make sure our website's up. Let's make sure our node is up. That looks good. Let's go to our website and let's try a sample transaction here. So if we go back to here, let's go find the contributing file. Let's go back down. Let's go find the mock token address. Okay, great. It's going to be this address here. Paste that in. Let's say recipients are going to be ourself. Amount, let's say, is just 100. Let's call send tokens. And okay, we get an approval transaction popping up. And my MetaMask actually says, this is a deceptive request. If you approve this request, you might lose your assets. Malicious address found in transaction. Something doesn't look right. So MetaMask comes with this tool called Blockade, which helps block malicious transactions. Since we're actually kind of testing and coding, like we don't care, especially because we're on the Anvil network. So Blockade, this is great, but you're kind of killing us here. We scroll down, we can see account balance, 100 MT, spending cap, 0.00001 MT, network fee, blah, blah, blah. We scroll all the way to the bottom. We can see data. We're calling the approve function on this contract for this amount. And this is actually correct. This is what we want. The confirm is red because, like I said, again, as of recording, the Blockade tool is telling us this is a deceptive request. But again, we're on a local blockchain and we're just kind of testing. So this is fine. So I'm going to go ahead and hit confirm. Request is suspicious. That's fine. And in my console.log, I have approval confirmed. And I have all these notes for the confirmed approval. Awesome. Okay, cool. So now I've got it confirmed. Well, once it's actually confirmed, then we want to actually call the function of airdrop, ERC20, right? So I'm going to say else. Let's call await write contract async. ABI is going to be the tsender ABI. Address is going to be the tsender address as OX $string. Oops. We're finally going to call drop ERC20. And now the args are going to be first the token address. Then we're going to need these recipients. So I'm going to kind of, and these once again can be new lines, they can be commas, they can be all this stuff. We could ask our AI. I'm going to tell you, it might be a little easier to cheat because your AI might screw this up. So if you go to components, airdrop form.tsx, if you want to scroll down here and just copy these args, don't worry, I'll explain this in a second. So this is kind of a cheaty way to get these. This is going to split the recipients up into new lines or commas, and it's going to remove all the white space, and it's going to remove all addresses that are blank. And then it's going to do the same thing with the amounts. It's going to split them all up. It's going to take out the new lines. We could have like a function that does this, and we probably would want to make sure that this code actually works, but I'm just going to say, go ahead and use this for now. And those args look pretty good to me. Something else we want to do though, and this is a little bit redundant and we probably could refactor this to make this a little bit better, is above in this conditional, after somebody approves, they should also call this. So now kind of the conditional says, okay, if approved amount is already good, just directly call the airdrop. And if it's not good, first approve and then directly call the airdrop, right? So we have both edge cases covered. There's probably a better way to refactor this code to do that, but I digress. So now that we've done that, let's go ahead, let's test this out on the UI. And this should essentially be the main functionality that we're looking for out of this. So I'm going to go back to the contributing. page to get that mock token address again. Let's copy this, go back to the tsender site, paste it in. Recipients are just going to say, you know what, let's choose Anvil 5 because Anvil 5 should not have any tokens. So let's just pick another address that doesn't have any tokens. Let's expand the view. So I have a different Anvil address added in here. I'm going to go ahead, tokens, import tokens, paste this in, next, import. Great, this person has 0. So I'm going to copy this address, paste this in here. Let's send them 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or yeah, 100, 1, 2, 3, 4, 5, or let's send them 10, 2, 3, 4, 5, 6, 7, 8, because the MT token has 18 decimals. So we'll send them this many. And let's go ahead and try this. So since I already approved, it should automatically just call the airdrop ERC20 function. Let's call this. And okay, this looks pretty good. Spending cap request. Oh no, it's calling the approval again. It's calling this cake NFT because I named it this, but this is actually the MT token. So let's recall it that. MT token. Okay. Spending cap is going to be 10 on the MT token. The spender is going to be this address here. This does indeed look like the tsender Anvil address. Okay, cool. And basically we're calling approve on the Anvil on the tsender for this amount. So let's go ahead and confirm. This is the Anvil chain, so I don't care. Yep, confirm, send it. And we see airdrop approval confirmed in our console.log. And then we immediately get prompted with another transaction, which is good. This is what we want. And if we scroll down, it's actually decoding our function to call airdrop ERC20 with the MT token. Parameter number 2 is Anvil number 5. Parameter number 3 is this much, and this is the total amount. So basically we're sending this much token to this address. This is good. Let's confirm. I have acknowledged. Let's confirm. And nothing happens because we didn't have anything print out. But if we go to back to our MetaMask here, let's go back to my account 8, which is the Anvil account 0. Let me refresh list. Let's go back to tokens. It now says I have 90 MT. And if I switch over to Anvil 5, now says I have 10 MT. So this worked perfectly. This is so exciting. Our UI actually works. It was able to call airdrop ERC20 with these fields and send a different address this much. Now we could add multiple recipients, we could add multiple amounts, and it should all work the same. If you want to go ahead and test that out, feel free to do so. But just to make sure, let's try this with some more addresses. So let's pick just another address, maybe one that's in your account already. Paste it in. We'll do another 10 here. Let's just make sure that our main address, our account 8, has enough. Okay, it has 90, so 10 plus 10 is 20, so that should be plenty. Remember that these tokens have 18 zeros, so this is the amount in here. That's great. So let's call it with 2 recipients and 2 amounts. Let's call send tokens. Okay, great. The first thing we're getting is an approval request. This is actually what we want. This is good. And again, Blockade is telling us this is potentially malicious, but we're on a local network, so we don't care. So it's saying we should be spending 20 on the tsender address. This is correct because we have 10 plus 10 is 20. Okay, awesome. That's good. We're calling approve on that address for this amount. Great. Let's go ahead and confirm this. Cool. And it looks like that went through. We have a little console.log out here. And okay, great. It immediately prompts us to call the airdrop ERC20 now that that's done. Item 1, item 2. And this time we have 2 addresses that we're sending. We're sending to Anvil 5 and account number 1, each for 10 tokens, obviously with 18 zeros each, for a total of 20. This looks correct as well. Let's confirm. And if I pull up my MetaMask, it looks like that actually went through. We can make sure it did. Let's go to Anvil 5. Oh, actually, let's just open MetaMask here. We'll go to Anvil 5. I'm going to refresh my list and wait a little bit for the MetaMask to catch up. This might take a few minutes. Might even just hard refresh the page. Go to tokens again. Aha! 10 was sent here. And let's go to the other address that I used. Oh, looks like I need to add this token. Import tokens. Paste it in. Next, import. And I see 10 tokens in here too. Oh, it worked! oh, this is this is so exciting. We actually have, at this point, a functioning, working, this is fantastic. And this is incredibly minimal. This is all the code that we need. So at this point, you should be incredibly excited for yourself because you've done some awesome work. You've built a minimal app using WAGMI, using these hooks to interact with the blockchain in a seamless way. And essentially, this is all the code that you needed. Obviously, this isn't the best user experience, right? When I hit send tokens, nothing on my UI kind of prompts the user that MetaMask popped up. If I cancel, it doesn't really tell me that there's an issue. I don't really know which token I'm working with here. And that can all be kind of an issue. So ideally, and the formatting of all this is kind of gross as well. Doesn't look very nice. There's a lot of work we can do to make this better. Additionally, ready, watch this, when I refresh the page, everything gets deleted, and that's kind of really annoying. So there's a lot of features we can add to this website to make it nicer, to make it easier for people to use, and add a lot of quality of life improvements. We're going to touch on some of those, but I am going to add them as a challenge. But basically, we have the functionality for this done, and this is incredibly exciting. So I'm going to go over some quality of life improvements we can give, and we're going to deploy to Fleek. But before we do that, I want you to take a break. And I want you to make sure that everything that we just went over, you actually understand, because we went through kind of a lot quickly. I skipped over some details, but this is where your AI friends are going to come in help a lot. A lot of this stuff can be really confusing, but be sure that anything you don't understand, you pop into your AI buddy, you ask on the GitHub repo associated with this course, etc., so that you can make sure you absolutely know what your website is doing. Because again, getting things absolutely correct is essential to working in the blockchain space. So for now, though, I want you to take a break, maybe go grab some ice cream, go grab some coffee, because getting this far is so fantastic. Congratulations for getting this. Take that break, go get some coffee, and I'll see you soon. All right, welcome back. At this point in your coding, you should have a very minimal website working. It should be able to take a token address, a list of recipients, and a list of amounts. When you call send tokens, MetaMask will pop up, prompt you, and you should be able to airdrop 20 tokens to multiple different people. It doesn't look very nice, doesn't perform very nice. So let's talk about some quality of life improvements that we can make. Now, I'm not going to have you do these. Now, I'm not going to walk you through these, but I am going to challenge you to pause the video and take some time to actually go through these and make these yourself. So here are the different quality of life features that I want you to add to this app, and you can refer back to my app to see how I did it. But I want you to try to do this yourself. And yes, you should use AI to help you here. So here's what I want you to add. Some quality of life features. You should both have a little spinner while the app is sending a transaction and while the MetaMask is popped up. So like if you're on your T-Sender here, well, and you had sufficient balance here and you called send tokens, when a MetaMask pops up, you get like a little spinner saying confirming in wallet. And additionally, when you confirm it, you should have a little spinner that says maybe mining transaction or sending transaction or waiting for it to go. That's like a nice piece of improvement. The next improvement is when you add a token, maybe add like a little box down here for transaction details. It says the token name, the amount in weight, and the amount of tokens. So for example, if I had 100, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it says, okay, that's this number in weight and this number in the tokens because it has 18 decimal places. If I added more tokens, it'll add them all up and put them in the bottom for this transaction details. It'll read the name of the token address. It'll read the name of the token based off the contract and place it down here. So it should have a little spinner for when you're sending. It should have a little box for the details of the token. And then finally, when you refresh, the inputs that you put in should stay the same. So this is going to be my challenge to you to work with an AI to add these features into here. Now, I'll give you a hint. I mean, obviously the final code that you can use is on the GitHub repo associated with this, but I'll give you a hint for all of these. You're going to want to be working with some use effects for a lot of these, saving some things to local storage. For the refreshing part, for the little spinner, you're going to want to have some conditionals on the button where you show a spinner depending on if you're confirming, if you're sending the transactions, etc. And for the little details box, you're going to want to read some details from the blockchain, like the decimals, the name, and the balance of the account.address. Something important to know is in the repo that I used this hook called use read contracts, which is a hook to make multiple calls in a single call. So you can read more about this in the documentation, but basically instead of calling decimals, name, and balance of in 3 separate API calls, you call all 3 of them in a single API call with use read contracts. And this will make your website more performant, and it's good to know and it's good to use. But those are going to be your hints. I highly recommend you take some time to do these challenges, because spending the time to work on this, work with the AI, work through the documentation, and then obviously refer back to my code when you get stuck is going to make you really, really good at understanding every single line of code that's going on here. So I highly recommend you pause the video, take some time to go through this, do these challenges, and come back. Now, these challenges might take a few days. They might take you a few hours. You might work with an AI and get them done in an hour. If it takes you a week, if it takes you a few days, if it takes you an hour, it doesn't matter. Just spend the time to go through these, refer back to my code to get ideas, to get inspiration. And I really want you to go through these, because it's doing these challenges that's really going to make you better. Remember, repetition is the mother of skill, and I want you to repeat doing a lot of these coding exercises to make you better so that you can understand everything that's going on. So pause the video, try to get through some of these yourself. And if you get lost, come to the code base to review, work with an AI, and I'll see you soon. All right, welcome back. So now we're going to get to our final piece of deploy to Fleek. However, I lied to you. We're not going to deploy to Fleek yet. We're going to take a quick stop at E2E testing. Now, I'm going to show you end-to-end testing, and we're going to show you what it looks like in the blockchain space and what it is and why it's important. However, we're not going to build a fully fledged end-to-end testing suite because, like I said, this is more of a crash course to really just introduce you to the main concepts of Web3 full stack engineering. And end-to-end testing is especially important for Web3 full stack engineering because, like I said, if you get something wrong, somebody says that a transaction that is incorrect, that's not good. So we want to make sure that our entire application does what we want it to do. So first, we're going to teach you the basics of E2E testing or end-to-end testing. And then finally, we're going to deploy this application to Fleek. Yes, you will have a website that you will have deployed, which is fantastic. And then we're going to be done with this section. So let's go ahead and talk about end-to-end testing. So if you ask in AI, it's going to give you a rundown of what end-to-end testing is. But essentially, it's a testing methodology that validates the entire application workflow from start to finish. And it gives a whole bunch of other contexts, an example of Cypress, some challenges, and it actually gives a pretty good definition. I'll give my definition as well. When we did this test here, this was known as a unit test. So a unit test is testing a single feature or a single function of your test. It's a very isolated test here. The definitions can be a bit of a gradient rather than super defined, but essentially the more isolated your testing is, the more of a unit test it is. So this test here is a unit test. Now, when we ran our code base and we showed up here, we added a contract address, we added some recipients, we added some amounts, we hit send tokens, MetaMask popped up, we hit review, we hit confirm, we checked the console.log, we checked the addresses. That was an example of a manual end-to-end test. That's us testing all the different features and all the different components and all the pages and all the functions all working together to make sure we get the final output and the final outcome that we want. For our application, the final outcome is obviously making sure that all the recipients get all their tokens based off the transactions that we create on our front end. Doing this manually is great. However, if we have 1,000 contracts, if we have 100 different options, if we have different buttons, if we have different spinning things, if we have different functionalities we want our website to do, well, it can be harder to manually test them every time we make a change. And it's much better if we have an automated way of testing all of this. And that's where our E2E testing of our full stack application comes into play. And this is incredibly important for working with Web3, once again, because why? Well, we want to make sure that the transactions that we create are correct. Yes, the user should validate them that they're actually correct, but we want to make sure that our application does what we want it to do, right? There's more egregious examples of why we want this to be correct, such as security reasons. But for the purpose of this course, this crash course, we want to just make sure that the website does what we want it to do. An incredibly basic thing that we could test for is, okay, when we disconnect and when we connect, our website shows what we want it to show. So if I disconnect here, right? Let me disconnect, then I refresh the page. Maybe what would be better is down here, it says, hey, please connect your wallet or something like that. So let's add one more feature to our website so that we can do a little end-to-end testing here. Let's make sure that when a user is not connected, nothing here shows up, right? So on the tsender website, if I go ahead and I disconnect my MetaMask here, it says, please connect to wallet. So let's add that functionality in. So in our components, let's actually make a new component called home content.tsx. And in here, we're just going to have a component that's literally just going to have the airdrop form only show up if we're connected. So let's go ahead, let's add this. So we'll do export default function, home content, and we'll do return div hi from home content. And instead of our page, and then we'll do import airdrop form from @components / airdrop form / components like that. And then we'll just do airdrop form, like this. And now for our page, there's our page. Instead of using the airdrop form, we'll import home content from @components / home content. And we'll do home content here instead. And now if I do a refresh on this page, it's showing the same thing. Okay, that's cool. So now let's just add a feature here where we check if we are actually connected. Now, WAGMI has a hook called useAccount, which comes with a variable called isConnected. So we'll do import useAccount from WAGMI. And in here, we can say const isConnected equals useAccount. And now in here, we'll just have a little conditional. We'll say, if we're not isConnected, ? Then we'll just say, div, please connect a wallet. We'll semicolon here. This is known as a tertiary operator. And if we are connected, then we'll say div, /div. We'll add the home content in here. And we can get rid of these, get rid of this, and we should put all of this inside of a div after all. So let's do this. And okay, cool. So now we have a little conditional, a little tertiary operator where if we're not connected, we'll say, please connect a wallet. Otherwise, we'll show this. And we can actually make this even easier. We can say, if we are connected, let's flip these. If we are connected, do this. And if we're not connected, do this. Maybe this is a little easier conceptually to read. So is connected, ? This is basically saying, if connected, show this. Otherwise, show this. So now that we have this code, let's go look at our front end. Let's do a little refresh. Attempt to call useAccount from the server, but useAccount is on the client. Oh, that's because I need to add useClient here. Let's save, refresh. Please connect a wallet. Let's connect MetaMask, connect. And now it shows the airdrop form. Let's go ahead. Let's disconnect. And it says, please connect a wallet. Okay, great. So let's test at least this functionality with end-to-end testing, right? And the reason I'm showing this is because this is a kind of a complicated thing to test, right? In order for us to test this, well, we have to connect our MetaMask, right? And that's kind of a weird thing to test programmatically. It's kind of easy to do manually, right? I just come to the website and I hit connect wallet, but how do we test this programmatically? Well, I'm going to teach you, my friends. And then you could use this power to go off and build Web3 applications where you actually do test the end-to-end functionality so that you make sure your website does what you want it to do, which as of today, a lot of projects don't do, which isn't great. So let's go ahead and let's test this. Now, to build this and to test this, we're going to be using a project called Synpress combined with a project called Playwright. Now, Synpress is an E2E testing framework based off Cypress. Now, Synpress is an E2E testing framework built by the Synthetics team. So Synthetics is a DeFi application. They've pioneered a lot of developer tools and strategies in the DeFi ecosystem, including, as it turns out, full stack development. And we're going to be using this tool to help us build our E2E testing. Now, it's an open source project. It's a little finicky to work with, but it's kind of the best that Web3 has as of today, which if you're interested in helping out the Synpress team, I highly recommend you do so, because as you'll find out, there's some gimmicky features as of recording that I would love to have smoothed out in the future. So what are we going to be testing here? Well, when we're connected, we see the airdrop form, and when we're disconnected, we do not. That's what we're going to test from an E2E testing perspective. So let's go to the Synpress documentation and let's get started here. So first, we need to add this in, and this is going to be a developer dependency. So we're actually, and let's kill everything. Let's kill that. Let's kill this. And we'll do pm add -d synthetics.io/synpress. This is going to be a developer dependency. This isn't needed to build the actual website. And we're going to be using Playwright because Playwright is a more popular E2E testing framework that a lot of full stack React projects use. So Synpress has plugins for both Playwright and Cypress. Cypress is another popular full stack testing framework, but we're going to be using Playwright because that's what I like better. So to get started with Playwright, we're going to run this initialization command. So this is the npm way to do this. They don't have the pm way to do this, but the pm way to do this is pm, and let's actually get rid of this so we can just focus on this. pm create Playwright at latest, and this will install Playwright and set everything up for us. It'll set up a folder, it'll set up configs, it'll set up a lot of things. Where to put end-to-end test? I'm actually going to put mine in test instead of test because that's where Synpress is going to look by default. So we're going to do that. Add GitHub Actions. We're going to say false. Install Playwright browsers. So Playwright runs a locally running browser to actually test, to actually automate the testing here. And you need to install Playwright browsers to get this done. So I'm going to say true. If you used Playwright before, you can probably say false. But if this is the first time working with Playwright, definitely say true. It's going to install different test browsers, such as a test Chromium, a test Firefox, etc. For us, we're going to be testing everything mainly on a Chromium type environment. But what's really nice about Playwright is it has support for different browsers. Historically, working with different browsers was kind of a huge pain in the butt. Like Internet Explorer only supported some things and Chrome and supported some things. But Playwright enables us to test kind of all these different oddities between these different browsers. It'll detect what environment you're working with and download the correct browsers accordingly. Okay, cool. So once you have everything set up, you get a whole bunch of different commands that you can start running to play with Playwright. So before we even get into some Synpress stuff, let's look at what we've created here. So in our folders here, we now have a test folder with an example spec.ts. This is going to be an example Playwright test here. We have some test examples, which show some more examples. For now, I'm going to actually delete the test examples because we're just going to show this example.spec.ts. If we scroll down in here, we also have a playwright.config.ts. So this is the configuration file for the Playwright tool. And now if I run pm exec playwright test, you'll actually see us run the example.spec.ts, and your computer, what will happen is your computer will actually spin up a little Playwright browser. It'll show you the tests that it's running. So in our example.spec.ts, we have a couple of functions in here. This looks really similar to the Vite test, unit tests, except for we have these new keywords like page, go to, expect, etc. Our first test has title is we have our browser go to playwright.dev, and we expect the page to have title of Playwright. Our second test is we go to a page, we click Get Started, and then we expect to see installation to be visible. This is a way to actually literally test working with a browser and making sure we see what we expect to see, which is really powerful. So back in here, I can hit this play button to run these two tests. I'll hit play, and you'll actually see the tests start to run, and you see that they both passed. What's cool is you can even kind of you can click on specific tests and see what renders at each step. So you can see, okay, when the test went to the playwright.dev site, this is what was shown. When it called expect to have title locator root, this is what was shown. You can see different after hooks, different before hooks. But this is a great way to really visualize what's going on in your tests when you actually run them. So this is a really powerful tool for us to write and run tests. We're going to do exactly this for our tsender application using SynPress. So for example, but before we do that, what if we deleted everything? We'll change this to await page.goto/. And in our playwright.config, we'll define what that slash is. In this use section, we're going to define the base URL to use in actions like await page.goto/. So I'm going to uncomment this line because when we run pm run dev, this is the URL that we're going to use. So this is how we can get await page.goto/ to point to this URL. Down here, to make our tests a little bit more efficient, I'm actually just going to only run this on Chromium to make this a little bit faster. And when we start up our tests here, we also want to start up our application. So we're going to do pm run dev and then reuse existing server. I'm just going to set this to true for now. Okay, cool. Now, if I rerun this command here, let's see what happens. Okay, this UI feature shows back up. It's going to load the tests in here, which I've just kind of minimized. So now we have example.spec.ts. All it's doing, remember, all it's doing in our test here is going to page./ and we're expecting to have title playwright. That's obviously going to be wrong because we have a different title. But let's hit play to see what happens. So now it's running our tests, and we see when we call await page.goto, we can see in this really tiny little window that it does indeed pull up our website. That's what it sees. That's what the browser sees. That's awesome. Now our test actually failed here. Expect to have title locator root because our title is different. So we go to errors. We see expected pattern playwright, receive string tsender. Well, that's actually correct. That's what we want to see. So let's cancel that. Await expect page.to have title tsender. Let's get rid of these and just do this. Or let's just add tsender in here. It's clear. Let's rerun this. So now we can pop open the UI. Let's hit play to see that if this passes, and we now see it does indeed passes. So when it does page.goto/, we see this little tiny little box here. We can even open this up to show what was shown in our Chromium. And we see this is what was shown, and that is correct. And our expect passes, and this is great. And obviously, if we want to rerun it without the UI popping up, we would just do pm exec playwright test. It'll run the tests, and we can run this little pm exec playwright show report. It'll show this little report with the tests that have passed, and then creates this little server. We'll hit Control-C to actually kill the server and move on. Okay, cool. So we actually have a basic playwright test where we make sure that our application has the title tsender. Awesome. So this already is a good ETE test for us to have. But let's keep going. Remember, what are we actually doing? We want to make sure that when we connect, we see the form, and when we disconnect, we do not. So how do we actually set that up? Well, in here, we're going to have to code somehow connecting to MetaMask. That sounds really hard. That sounds like a really hard thing to code. So this is where SynPress actually comes into play. SynPress is going to have a lot of this code, a lot of this boilerplate to connect to MetaMask, work with wallets, etc. So let's keep going through the instructions here. So now that we've installed Playwright, we've installed SynPress, we want to make sure our playwright.config.ts is correct. So let's go to our playwright.config.ts and let's make sure it has everything needed for us to work here. I'm going to hard code some things for now, but when you go to run production, feel free to review my playwright.config.ts for some different updates. For workers, I'm just going to set 1 here. For fully parallel, I'm actually going to put false for now, but if you're using a CI, it's probably a good idea to do so. And that's it. So if you want to just copy paste mine though, you're more than free to do that. So that looks good now. Then create a basic wallet setup file. So the way that Synpress works is it first needs to define a MetaMask, a wallet that we're going to use. And when we run our test, that's going to be the MetaMask that it's actually going to connect for us. So we're going to do this. We're going to create a basic wallet setup file. In our test folder, we're actually going to create a new folder, one called Playwright. And we're going to take our example.spec.ts and put it in there. I'm actually going to rename it to basic.spec.ts. And we're going to create another file or another folder called wallet setup. And in here, we're going to create basic.setup.ts. And this is going to be our basic wallet setup. If you want to have more complicated wallet setups, this wallet setup folder is where you would do so. Now, now we're going to copy what's in the docs, but what we're going to use might be a little bit different than what's in the docs. So this is good. So this is pretty good. Ideally, these are environment variables. It's not great to have them in plain text here, but it's not the end of the world. But this is essentially our wallet setup, which is fine. And when Synpress connects a MetaMask to our app, it's going to connect a MetaMask with this seed phrase and this password. So if we wanted it to default load up with the seed phrase from Anvil, we obviously would use the Anvil seed phrase here, which I think this actually might be the Anvil seed phrase. Test. Oh, so that is the Anvil seed phrase. Okay, perfect. Now, the next thing it's telling us to do is create a test file. So we already have a test file, but we're going to update it with some of this Synpress stuff. So in our basic.spec.ts, let's update this to our test that we want to run, right? We want to make sure when we're disconnected, we don't show the form. And when we are connected, we show the form. Let's create a new test. It says, should show the airdrop form when connected, otherwise not. Do a comma, async, function, arrow, like this. This is going to be the basic setup. This is some classic JavaScript testing here, where you say test, kind of the name of the test, and it's an async function, and the details of the function are in here. So in this actual function, we want to first check we see please connect wallet. So the first thing we can do is we can check for that. Whenever we call one of these functions, we want to add some different keywords such as page. So we're going to pass in the page to this function. And I can do await expect page.get by text. This allows me to find any part of the page by text. Please connect. To be visible. So when we start up the site, we should see please connect when we are not connected. And then to test this, I can do pnpm exec playwright test. And we should see both of these pass. Oh, and we actually see an issue here. Of course that fails because I need to go to the page first. So let's do await page.go to here. And then let's look for this. And then we can run the test like here. And it passes. Okay, great. So we see please connect. Well, we could be more specific. We do like please connect wallet, ... But for now, I'm just going to leave please connect here. So now we want to actually, well, what do we want to do? Well, we want to connect our wallet to MetaMask so that we see the form here. So how do we do that? Well, this is where we're going to have to use Synpress to get set up. So first thing, we're going to import this basic wallet setup here, because this is how we're going to set up our wallet. So we're going to say import basic setup from /wallet setup /basic.setup. We're also going to import test with Synpress from @synthetics.io /Synpress like this. And we're going to need to import MetaMask, MetaMask, and MetaMask fixtures from at synthetics.io/synpress/playwright. So now we're going to update our test. Instead of pulling from Playwright here, we're going to delete this, and we're going to use the test from synpress because this is going to come with a lot of helpful features. So we're going to say const test equals test with synpress. In here, we're going to add MetaMask fixtures, basic setup. And then we're going to say const expect equals test. And we'll get rid of this for now. We could, we'll leave it. So what's going to happen here is this MetaMask fixtures function is going to take our basic setup file and use this to create a MetaMask. It's going to add this MetaMask fixture into our test with synpress function, which we're going to get this test keyword, which has a lot of this MetaMask setup already set up for us. And then, of course, we're going to extract the expect function out of this as well. Now what we can do is after we run our test to make sure it starts off as blank, we can actually connect to MetaMask. So we'll say const MetaMask equals new MetaMask, and then we'll have to add a lot of stuff in here. But this function is going to come with a few other things. It's going to come with a context, MetaMask page, and extension ID. And we can call new MetaMask with these pieces of context, MetaMask page. We'll do basic setup, wallet password, and extension ID. So these objects come with our test with synpress, and they help us set up a MetaMask here. So this is just the MetaMask object, but we actually want to connect here. So we'll do await page.get by test ID RK connect button. And what this RK connect button is, if we go back to, am I running the site? No, let's run the site real quick. pm run dev. If I go back to the site here, let's disconnect. I hit inspect. Inside this body tag, I can see what this connect button looks like. It's really, really tiny here. Data test ID equals RK connect button. So in my test here, I can say page.get by test ID, RK connect button, dot click. And this is how I actually click that button to connect my MetaMask. Now, when you click it, if I click connect wallet, we now have this section here, which is, if I right click on this and hit inspect, it'll bring me to this div here. And if we look in here, we see it's called RK Wallet Option IO MetaMask. So we're going to click that. So we'll do await page.get by test ID RK Wallet Option IO .MetaMask. Let's first do dot wait for state visible timeout 3000. Or is that 30,000? Yep, 30,000 or visible. Excuse me. Okay. So first we want to wait for that thing to show up, right? Because when we click it, it takes a second for it to pop up. So we'll wait for it to be visible. Then we'll do await. We'll do the exact same thing, but we'll click that thing, which is the RK Wallet Option IO MetaMask. So we'll click that to connect to MetaMask. And then we'll call await MetaMask.connect to DApp. And this is kind of the key functionality that synpress gives us out of the box. This connect to DApp will spin up a MetaMask for us, and it'll spin up a MetaMask for us based off of our basic setup, and it'll connect. So now I can run pm exec playwright test. I'm going to do -- UI again, so I can actually see it with the UI here. Make sure it's actually doing what I want it to do. And now we can see we have our two tests that haven't run. Let's just run our second test here. We'll hit play. And we get this error. Cache for this does not exist. Create it first. This is one of the gimmicky things with synpress that I haven't shown you yet. So first we actually need to do pm synpress to create a cache. And it says building a cache. That's because somehow I added a space in here. Whoops. Let's try that again. CLI is an alpha, so expect breaking changes. Building the cache for wallet setup. And what this is going to do, it's going to download the MetaMask extension. And MetaMask is actually going to pop up. It's going to create a password. It's going to basically create a wallet for us. It's going to save it to a little. Now that error that we ran into, if we actually run our exec again, we're actually going to run into that error again. We're going to get a little, well, as of today, we get this error because I first need to go to my playwright.config and I need to change this, get rid of that space. Whoops. Let's run the test again. Can't believe I put a space in there. That's so bizarre. Now, run this again. We're still going to get that error. It's going to say, hey, no cache does not exist. Create it first. We just copy this cache name here and we go up to our cache and we just rename this to what it expects for our test. So that's a little bit of the gimmick for the application right now. I expect in the future that to be a much simpler, smoother process. But now we can run this one more time and we'll get the UI to pop up and we'll get all of our tests to be in here. What we can do now is we can run this and we will see it running. We'll see it even pop up. We'll see the password get put in and we'll see it connect our wallet. And it's kind of going crazy because everything's being automated. But oh my goodness, all this crazy stuff happened and we can see kind of the flow of all the windows being open. So first it went to the extension, popped open MetaMask here. Let's pull this down here. It went to the main page. It expected the text to be visible, which it did see. It pressed the connect button. The module popped open, and I know this is super, super small because there's so much text here. It went to the MetaMask module. Then it loaded up after a whole bunch of calls. It loaded up the MetaMask extension, put in the password, and connected to MetaMask through the app. And then finally, all the way down at the bottom, that was it because I forgot to check to see that we're actually connected here. Whoops. So now what we can do, let's go ahead and kill the UI here. Now we can do await page.get by role. Let's look for just any text box, comma, with name, OX, exec. We could say true. Why not? What are our placeholders? Let's go back to our airdrop form. Airdrop form. Let's look for placeholder OX. Okay, cool. So we'll just look for it in a text box. Look for OX in there. Dot wait for state visible timeout 30,000. So we're basically expecting to see one text box with this in there. We could check for all of our other placeholders as well, but let's at least just do this one. And we'll run this. We'll get our UI to get spun up. And I'm going to hit play and windows are going to pop open all over the place for me. And they should for you too. Yep, they're going crazy. You can't even see some of them. But it's automatically connecting, automatically setting up MetaMask for us, which is super exciting. Automatically clicking buttons and automatically checking to see if it sees what we expect it to see. 30,000 is probably too long. Oh, and it actually failed here. So you didn't quite finish opening. We need to finish adding a network in here. So let's actually do that too. So we'll do connected app. We'll do const custom network equals. This will be name Anvil. RPC URL. It's going to be http://127.0.0.18545. Chain ID 31337. Symbol will be ETH. And then await metamask.add network custom network. And now let's try this again. This time in our terminal, we'll first do pm Anvil. Spin up an Anvil chain. Now let's do our test here, and it should work this time. Let's run our airdrop test, and we're going to see windows fly open all over the place, connected to MetaMask, adding MetaMask. We're also going to add a new network. We're going to connect, add a network, change to the Anvil chain, and then we're going to finally check to see that we have that section added. God, I'm an idiot. And I'm an idiot because this isn't the name of it. It's not OX. Sorry. We're going to do, what are we looking for? My mistake. We're looking for token address, recipients, amounts, any of these to be visible. So let's look for token address. Sorry about that. Instead of this, apologies, we'll do await, expect. That's what we're looking for. Page.get by text. Token address to be visible. That's what we're expecting, not the weird placeholder thing. So we don't have to add this custom network, but in the future, if we want to do cool stuff with Anvil, we would obviously need to add Anvil. So let's run this one more time with our Anvil node running, and let's see what we get. We'll play here on the UI, and everything's running, connected to Anvil. Now it's going to finally be looking for that page, and we see a check mark here because it did indeed pass. And that's so exciting. We can see down in the tiny little box here, we can see the finalized UI connected to MetaMask. And of course, we can run that again without the UI as kind of like a regular test by just removing the -- UI bit. And if we do have Anvil bit set up, and if you do have the Anvil bit set up, you'll want to have your Anvil node running. You'll still have kind of MetaMask pop up and go a little bit crazy, like what we're saying here. And now we do indeed see 2 passed. So this is kind of an introductory to this thing called Playwright and Synpress, but it is a really cool way for us to work with MetaMask and do more complicated things like connecting to MetaMask. And then we can go even farther, like sending transactions, doing approvals, and making sure, we send the right information and we see different spinners and, the correct stuff show up for the user when certain inputs are set up. So when we're making more advanced full stack applications, we want to be testing end to end. And this is how we can do it. Use something like Synpress, something like Playwright, which downloads the MetaMask extension. It sets up a cache for us, etc. All of that is incredibly helpful. Now we can, of course, in our .getignore, we probably want to add cache Synpress. So we'll add Synpress .cache Synpress. This way we don't accidentally push up our Synpress cache to our GitHub repos. But this is exciting. So we learned how to do some ETE testing. When we connect, we see the form. We just tested that. And when we disconnect, we don't, right? That was in our basic.spec here. First we see please connect. Then we connect with all this code. And then we see the token address. And we could add more details like recipients, amounts, blah, blah, blah. Exciting. All right, great. So we did ETE testing here. And now the final thing, possibly one of the most important things, is we want to deploy this. So once we're happy with our website, which especially for hackathons, you really want to deploy your demos so that judges can actually interact with it and play with it, you're going to want to deploy it. Now there's lots of ways to deploy full stack applications, and I'm just going to show you one of many. We're going to be working with Fleek, Fleek.xyz. Now, the reason I like Fleek so much is that Fleek can create static sites for you. It has a ton of Web3 plugins, and it has something called Fleek functions, which enable us to do even cooler things than what we're going to show you here. So we're going to use Fleek to deploy our site, and we're actually going to make one more change to our code base so that we can deploy it as a static site. Because as of right now, we're actually not quite a static site. So a static site is going to be a site that can be 100% on the browser, on the user's end. Whereas a dynamic site will be a site that has a server that does some rendering or does some compute, etc. For a lot of Web3 applications, we want them to be 100% static, 100% on the client side, because that's the Web3 way, right? Open source, nothing running on a closed source server. Have the user do everything. And that can be really nice for us as developers and infrastructure creators, because if it's a static site, well, we don't really need to run a server that does anything other than just, give people the HTML and JS. Once again, work with your AI buddies to learn more. But basically deploying your site statically is something that a lot of applications want to do and are really good and are incredibly minimal. However, in our next section, we will show you some really nice add-ons where you have a server which adds some really nice quality of life features, but obviously now you have to run a server. Now you have some additional infrastructure costs for running a website. But like I said, for what we're doing here, 100% static, very low infrastructure costs, and we're going to use Fleek to actually do all the deployment. So In order for us to first get started working with, we need to sign up or log in. You can use a wallet or an email. I'm going to log in with an email. Once you've signed up or logged in, we want to go over to the dashboard. And this is going to be our dashboard for our first project. You can also hit create project to do whatever you want to do here. And we're going to go to the hosting site, and we're going to be adding a new site in here. Before we actually deploy to Fleek, we want to make sure that our code can even compile to being a static site. So what we want to do is we want to go to our next.config.ts, and we want to set output to be export. This means that when we build our application, it'll build it as a static site. Additionally, we can add some other options. I'm going to add dist-dir is going to be out. So that's the name of the place it'll compile to. And then we'll do images unoptimized to be true, because optimized images only work on the server and we don't want any server running stuff. We'll add a base path of blank asset prefix dot slash, and then finally trailing slash to be true, because this is something that Fleek is going to be looking for. Export default next config or module.exports equals next config, either way. And then we want to run pm next build. And if this successfully builds as a static site, then we know that Fleek will be able to build it as a static site as well. So we'll run this and we'll wait a little bit. And great, finalizing page optimization, pre-rendered as static content. That is exactly what we're looking for. Okay, cool. So now we can come to Fleek and we can go add new, deploy my site. And to deploy your site, you're gonna have to connect and deploy to a code location. As of recording, they only show GitHub. So we're gonna have to connect this to GitHub. And I am so happy that Fleek forces you to connect to GitHub, because you should be pushing your code up to GitHub anyways. Why? Because version control is incredibly important, and because GitHub is going to be your portfolio. We're going to be showing off your projects and how badass of a developer that you actually are. And for deploying your sites, you're going to need to have a GitHub as well. So if you don't have a GitHub, now's the time to create a GitHub and deploy your site to it. Now, if you've never used GitHub before, AIs are phenomenal at working with Git and GitHub. And I highly recommend you learn how to upload your site from your Git. So we can go to github.com. I'm already signed in, but for me, I'm going to hit new. I'm going to call it tstsender UI cu. We're going to make this public, create repository. And now I have this new repo here, and I'm going to push my code up. Git add remote origin, paste this link in here. Oh, first in my code base, I'm going to do git init. Initialize a repository, and you'll see a whole bunch of green stuff show up in here. Then we can run git status, and we can see which files that we would push up. We want to just run through these and make sure that these are the files we want to push to GitHub. Remember, this is what we're going to be pushing publicly. If you've never worked with GitHub before, be sure to ask your AI lots of questions. Yes, I want to add this. Yes, I want to add this. Yes, 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 yes. What we want to make sure is not in there is .env.local, any of this, cache simpress, .next, node modules, out, Playwright, report, test results, env local, env, next env.d.ts. I don't see any of those in the output here. So great. So what I'll do is I'll do git add period, git status. Now I'll see a ton of green files. These are going to be all of the files that I'm going to push up to GitHub that I'm going to push publicly. They look good to me, so I'll do git commit -m, my first commit, enter. Then I'll do git remote add origin, and I'll copy the link of the repo that I just created, paste it here. Then I'll do git push origin, setup stream origin main. And if you're not signed in, you might have to sign in. You download the GitHub CLI to do this. You could work with Git directly to do this. There's lots of different ways to do this. I'm going to cheat a little bit. I cheated a little bit and I pushed it up off stream. But now if we go here, I can see all of my code up on GitHub, which is incredibly exciting. Cool. And if this is your first time pushing up to GitHub, I know I didn't show you step by step here, but you should be pumped about yourself. And you should copy paste this and post it on Twitter that you posted to GitHub for your first time. You're actually becoming a developer. You're actually becoming an engineer. But actually, you know what? Never mind. Don't celebrate yet. Let's deploy the site and then you can celebrate. So we're going to select GitHub as our option here. And resources on your account, all it does is view our email. And Fleek is asking to get access to our GitHub. All it's going to do is be able to read our email address. So we're going to go ahead and authorize that. Authentication complete. Okay, great. So now it's going to ask us to install the Fleek app on GitHub. We're going to add it to our GitHub. And we want to be a little bit more secure. We're going to say only select repositories. And we're going to get that TS tsender UI safe for an updraft. Install and authorize. Authentication complete. This is going to add some GitHub actions to our GitHub. Now it's going to say, do you want to deploy this site? We're going to say, yeah, we want to deploy this site. It's auto detecting. It's a Next.js site. And this is where we can add the key features here. So yes, we want to be on the main branch. Yes, we want to look in the out directory. And then let's look at the build command. We can copy paste it in our repo to make sure that it is the correct command that it's running here. pm install and pm build. pm install and pm run build. Those look correct to me. I'm able to create a static site locally. So, okay, those look right. Let's show advanced options just in case. Base directory looks fine. And we do need some environment variables actually. So let's grab our environment variable from our .env.local and the project ID here, paste it in. We'll hit add. We'll add it in here. And then we'll go ahead and deploy the site. And that's it, I hope. Now we can go to our site and we can see that our deployment is indeed building. So it's actually building a website for us to view and for us to hang out with. If you go to the repository you created and you're fast enough here, you might see a little yellow orange dot here where it's saying Fleek is building our site, which is very exciting. We can go to the deployments tab and we can kind of check on how this is doing by looking at the logs here. So it successfully cloned the repo. It did a little check run. Now it's building the logs. And now it's actually building this site. So it's running that pm next or pm run build here. Then it'll upload to IPFS, check the availability of the domain, and then release it. And we will have a website deployed automatically for us through Fleek. And it'll be uploaded to IPFS. Now, IPFS is a phenomenal hosting platform for 100% static sites. It's not going to be something I go over too deeply here, but I highly recommend you check out IPFS. And you learn about IPFS because it is a very powerful tool for deploying static sites with decentralized front ends. Now, if you run into an error here, and quite often you'll see something like this directory does not exist, like what you see here. This is kind of the default error that Fleek will give you on the UI. And this basically just means that something happened in the build step that failed and it was unable to deploy. So I found a lot more success with, instead of using UI, you use the command line for Fleek instead. So let's go ahead and let's use the command line. So actually on my dashboard, we have npm install -g at Fleek platform/CLI. I'm actually going to copy this and run this on my terminal. And this will install the Fleek CLI. This will allow us to actually deploy our sites directly from our code terminals. And this is, in my opinion, a lot better because we can actually test exactly what is going to be compiled and deployed, etc. And to make sure everything works, like I said, I found Fleek is a little bit happier with npm. So we want to just make sure that npm install works correctly. And then we also want to make sure that npm run build or npx next build works correctly. Something important to note is in our tsconfig.json, we want to make sure that everything in the test folder, so we can do something like this, everything in the test folder is actually ignored. This way, when we do a build of our next project, it'll not add anything in the test folder, which is what we want. So it looks like our npm install worked. Then we can do npm run build or npx next build. And if this creates a static site successfully, then we should be able to use the CLI to also deploy a static site. All right, great. We see static here. So this means we should be able to deploy our static site with Fleek. So now we can use the Fleek CLI to deploy our site. The first thing that we're going to do is we're going to need to log in. So the Fleek CLI is really easy to log in. We just do Fleek login. We get to click this link or copy paste this link, and we can go ahead and confirm, and we can visit the dashboard, or we can go back to our CLI. It says success. You are now logged into the Fleek platform. Now we can run Fleek sites init. It says warning, to proceed, please select the project. And I already have a first project created. So that's what I'm going to be using here, the first project. We found existing sites. Would you like to link to one of them? I'm going to say no. We're going to create a brand new site. I'm going to call this tsender2. You can call it whatever you want. tsender2 has been successfully created. Please specify the directory containing the site files to be uploaded. So we want to upload the out directory because this is the compiled code. This is the static site built code. So we could do /out like that. Would you like to include an optional build command? I'm going to say yes. npm run build is great. I'm going to use the JSON. I've found the most success with the JSON, and then we'll do clear. And if we open that fleek.config.json, we see we're given a random slug for a URL, the dist directory, which is our out folder, and then the build command. Now that we have that, we can just do Fleek sites deploy, and it'll build our application locally and then deploy it. And this is why I like doing this from the CLI instead of the UI, is because we get to build it locally and we get to see exactly what's happened a lot easier. Once you get to this part, you should see some success here. And then it'll upload this to IPFS and give you a URL for application. Now, this might take some time, so feel free to maybe go get a coffee, go get some ice cream, go for a quick walk, because this can take 5 to 10 minutes to actually finish deploying. Or actually, mine deployed super quickly, and we get this output here if we're successful. It was deployed to IPFS, and we can see the site by command clicking this or open this in a URL. And oh my goodness, our site is actually deployed to a website. Let's try to connect our wallet here with MetaMask. And oh my goodness, it actually connects. It actually is connected to our Anvil. So hold on, let's do a little PM Anvil. Let's see if we can do our goodie stuff here. We are connected. Let's connect. Let's change our accounts to our account 8. Let's add our address here. Let's add a different address here. Let's say 100. Let's do send tokens. Let's inspect, see what's going wrong here. Inspect. Oh, we're getting an error here. We need to turn our Brave shields off for this. Let's try again. Let's do 100 to send tokens. Our MetaMask does indeed pop up. Blockade is blocking it, which is good, but we're going to ignore you. Confirm. We get a console log with the approval amount. Okay, this pops back up. Let's confirm again. Yes, confirm. Okay, so now let's grab this token address. Let's pop it into our new account. Tokens, import tokens, paste this here. Oh, and we can see we were given the tokens on this contract address. It's like 0.00001 because we only sent 100 and it has 18 decimals, but awesome. We actually deployed our website using Fleek, using the CLI. And now we have a 100% static site deployed using Fleek, and it was deployed instantly all through our command line, which was much easier to use. And this is a static site deployed to IPFS as well. And if we go back to our Fleek UI and we do a little refresh now, for our sites, there should now be a tsender2. Yep, we see that here. We can see a little preview here. We can see that it is deployed and it is ready. We can see it is deployed to IPFS and everything about this site. So Fleek has made it really easy to automatically deploy our site, IPFS, and URL automatically. Now, if you want to go one step further, you can also attach a domain, like for example, tsender.com, obviously, and not kind of this wonky, hissing petabyte square, blah, blah, blah. It is at this much nicer domain. And like I said, this has a lot of the quality of life improvements. So it's much more responsive. It's nicer to read than our kind of growth site here. But this is super exciting. You have deployed a website with Web3, with blockchain functionality. You should be incredibly proud of yourself. And if you want to go so far to make an even cooler website than the T, please do so. Then send me a link, because if your website is cooler than my website, well, I want to use it. Because like I said, the tsender site is one of the sites that is actually used to do Codehawk's payouts. Well, I should say more specifically, The tsender code base is what's used to do CodeHawk's payouts. And sometimes the tsender UI is used, sometimes it is not. But in any case, this is incredibly exciting because guess what? You just did the final step in our section 2 here. You have deployed to Fleek. This is fantastic. All right, this is so exciting. You should be so proud of yourself. So if you haven't been following along with me, guess what? Your next challenge is to do exactly what we just did. Deploy your own site to Fleek. Now, you don't even have to deploy the tsender codebase that we just set. Just deploy something to Fleek. You can use the CLI, you can use the website, whatever you want. This is going to deploy to IPFS, give you a URL. Once you do that, you should come back here and click this link. This is a tweet generator link. It'll automatically create some text for you. I just deployed a Next.js site using Fleek that can connect to ZK Sync. Thanks, Patrick Alpha C and Cypher and Updraft. And hit post. Let us know that you've done this because this is incredibly exciting and you should be super proud of yourself. Whew. So please. Now, like I said, doing these challenges is incredibly important, and getting your first website up is going to be incredibly helpful for your confidence and for your portfolio. So definitely be sure to deploy this to Fleek. Definitely be sure to tweet this out at us. The Fleek team and the ZK Sync team, they love seeing developers thrive in this ecosystem. They love seeing developers thrive and build really cool things. And maybe you'll find some friends along the way. So be sure to celebrate the wins. Be sure to actually deploy this site and then tweet it out. So pause the video, make sure you get this done, and I'll see you soon. Okay, welcome back. Hopefully you deployed your site because that is what's going to give you the skills here. Repetition is the mother of skill, and we want to make you incredibly skillful. So we need to repeat this. We need to have you deploy a lot of sites so you get really comfortable deploying these sites and working with these sites. Hopefully you actually did the challenges above here as well, where you added in your own quality of life features. And hopefully now you have a successful website up, deployed to IPFS, and you are incredibly proud of yourself. And we are incredibly happy with you. So in this section, we learned a lot. There was a lot of stuff that we went over in a very short amount of time. And I had you use AI a lot to substitute some of the learnings in here because there's a lot of full stack learnings that we kind of skimped over here so that we could focus purely on the Web3 aspects. So let's go over all the things that we learned here in a quick review, and then we'll finally go to the final section. So first of all, we learned how to build a more production-ready code base using Next.js. Why did we use Next.js? Why did we use React? Well, it allows us to build more modular websites that have both JavaScript and HTML combined, or in our case, TypeScript. We first got started with our Rainbow Kit, which allowed us to build a really pretty connect button on our website. It allowed us to very easily switch between supported networks and automatically have our wallets update to those nicer networks. We learned we could create little customizable components like what we saw here. We made a header component and a airdrop form component. We created this giant component, this airdrop form, which used a ton of React hooks and used a lot of these WAGMI functionalities, such as read contract, wait for transaction receipt, use chain ID, use config, use account, use write contract, for us to actually interact with these blockchain applications. We created a little flow here for us to both approve our contract using write contract async, using the await keyword, and then contract async as well to actually call the airdrop ERC20. We used AI to help us make a nice little input field so that we didn't have to make it. And we learned that, especially for kind of these dull things like creating a little input field, AI can really accelerate our development journey here. We learned that we can create different utils and we can create tests for them right alongside the main files. And if we want to actually test them, we can run pm run test unit like this, and we can test our functionality to make sure it does what we want it to do. Not only did we learn how to write some unit tests for our code base, but then we also learned how to run end-to-end tests with Playwright and Synpress. For us to write a Synpress end-to-end test, we could do pm run test, or pm exec Playwright test. And since we're using Synpress, this automatically had us install a MetaMask instance into our test environment so we could test what it's like to connect to MetaMask, work with MetaMask, etc. We didn't go super deep into working with SynPress, but if you want to go deeper throughout the documentation to learn more, you can absolutely do so. One of the coolest things about Playwright is that, and I actually just ran it and I ran into an error because I didn't have Anvil running. But if you want to go deeper onto working with Playwright, working with SynPress, I highly recommend you do so because, like we said, you really want to make sure that your code actually works when you're building these full stack applications. So we created a basic Next.js React application. We used the Rainbow Kit to make our connect button much prettier and much smarter and much more functional. We implemented our Airdrop ERC20 contract using WAGMI React hooks. We did some end-to-end testing. And then finally, we used the Fleek CLI to deploy our application to an IPFS instance and have a website right here. We could have also used the UI, but we ran into some issues here. So if you want to go back and try to figure out how to get the UI to work, great, go for it. But like we said, when we build locally with the CLI, we can see directly what's going on to make sure that everything works perfectly and we get our site up. Whew. So this was an absolutely jam-packed section and kind of a huge jump from the HTML TypeScript section to this React Next.js section. There is a lot to learn here. And AIs are really helpful at getting a lot of the basics. Like I said, AI was actually able to generate a lot of the code that we wrote here for us, which was great. We want to use AI. We want AI to be our companion, but we cannot trust it 100%. So the Siphon team, the team that I work on, we get auditors, we get smart contract developers who send us AI generated code pretty often. And it's kind of a nightmare for us because the amount of bugs that we find in this AI generated smart contract code is a lot. Like I said, especially for smart contract code, if you mess something up, you could be out $1.5 billion. Or even on your front end, if you have a security vulnerability, same thing. And we do not want to have security vulnerabilities. So the biggest thing I want you to take away from this is whenever you work with AI, whenever AI gives you some code, you should be going through it line by line, making sure that it's not giving you anything dumb. If you do not understand a line of code that the AI gives you, you should not use it. Make sure you understand everything that's going on. Treat your AI companions like kind of a stupid college student who will just, figure something out and give you the code base, but they're not the experts. You are the expert. So like I've been saying, repetition is the mother of skill, and we want you to be incredibly skillful, so we will have you do a lot of repetition. The more you repeat this, the better you'll get, and the better you'll get at very quickly understanding if the AI is telling you something stupid or telling you something intelligent. So, with this being said, huge congratulations on finishing this section. Now's a great time to go get some ice cream, go get some coffee, go for a walk, and I'll see you in the next one.